Hey guys, and welcome back to a new free course here on YouTube. And I think this is going to be one of the most fun ones that I've ever made here on YouTube, specifically covering Kotlin and Compose Multiplatform. Because, I thought I already have quite a lot of such free courses. So I made a video course about building a book application where we load books from an API. I made a course about a crypto tracker application where you can track all the different crypto coins and coin charts. I made a course about a note-taking app. I made a course about a dictionary app. But all these courses that I've made already are quite similar in the sense that we've built Bliss screen, detail screen, we maybe loaded some data from an API or a local database or both, show that in the list screen and then shows specific item details when clicking on that. And that is, of course, super helpful to understand and know as a mobile developer. But there is actually more to the mobile development world, which is something we're going to take a look at in this course, because we are going to build a meme creator app. So the way this works here is, this is really what we will build here in this video. We will have a list of meme templates where you can see those aren't finalized memes. There aren't any text. Those are really just the templates where we as the users can then insert text and we can become creative to create our very own memes. So for example, let's choose this Drake meme here. We click on that, then we open our meme editor screen where we can then click add text, and then we get a text here. We can drag this around, and actually not just drag this around, but we can freely transform this. This I now have to do with my fingers here. So we can rotate this, we can scale it, we can also put it over multiple lines. And if we then double tap here to edit this, then we can type some text. So for example, learning with Google. Move this in here, then add another text, move that here, and we say, okay, learning with PL coding, for example. And then here we have our meme. We can click Save Meme. Our share sheet will open up, which we can also use to save something. Also, optionally, you can say, I want to share this with my friends in WhatsApp, whatever. These ads will appear here. But there's also, for example, this Files by Google app, which you can click, and then it will be saved. And then here's our new meme that we've created. So we can really export this to our gallery. And if you've listened carefully, then we're going to build this in Kotlin and Compose Multiplatform, which means there is also going to be an iOS version of this app. So here, this is the iPhone 16 simulator, and it will work just like on Android here. So we can also open a meme. We can also add text here. We can also drag this around, and we can also save this here with the iOS native share sheet, where we can then say save image, and then if we go to our gallery here, photos, then here is our new meme. Since this is already going to be a lot of work, especially with this meme editor, I will leave out desktop here and also Compose for web, which you could technically fairly easy extend this app with. In the end, you would have to define some platform-specific things here for the desktop and web platform. But after having done that, you really also extend the same app here to a browser and to a desktop platform. If you want to get into Compose Multiplatform for web, then I actually recently made an introduction video about that, which I'll link somewhere here. But in this course, we're going to focus on the mobile sides. And also very worth mentioning here before we really get into taking a closer look at what we'll build and how we'll build this. This course is actually sponsored by JetBrains, so by the makers of Kotlin and Compose Multiplatform itself. Okay, but how do we approach this? Because this is obviously a bigger project. Let's do this step by step and understand what is even necessary and have a little bit of planning before we dive into coding. On the one hand, what kinds of prerequisites in regards to technical skills do you need to bring if you want to really follow through this course here and understand things? There's actually not a lot, but a little bit. And so what you definitely need to know is Kotlin as a language. I won't explain here what a Kotlin class or Kotlin variable is. That is something, and those are concepts that you should already bring. You don't need to be the Kotlin expert, but you should be familiar with the basic language concepts. And additionally, Compose basics. So we're using Compose Multiplatform here. You should be familiar with basic Jetpack Compose components in order to build UI. You should know what a row is, what a column is, what a box is, how we maybe render text. You don't need to be a Compose pro as well. And especially here with this more complex part of this project where we build this meme editor with dragging around, with rotating, I will go into very, very detail here with my explanations. But these basics you should already be familiar with. In case not, then I luckily also have a Jetpack Compose crash course here on YouTube, I think 50 minutes or so, after which you should definitely know what you need to know in order to follow through this one. So what will you actually learn in this course? As I mentioned, and as you've seen, this is not the typical list detail screen app. Also, we're not really working with a remote API here. We're not really working with a local database in this case. These are super important concepts, and if you want to learn these, then I have courses about these. For example, the Bookpedia course, in which we've built a book app where you can browse and search through books from an API and also save these locally. But here I explicitly wanted to do something different, because I can imagine that there are many beginners among you who don't even have a slight idea how they would approach such an app with such a meme creator, where you can really edit such a meme, drag text around, and also export these as a real image. And that will be a very, very big learning here for you. So you will learn how to work with the file system on both platforms, how you work with URIs and what a URI really is. You will get into more advanced Compose concepts, especially here when coming to this meme creator, how you can implement really 2D drag and transformations. And you will learn a lot about image rendering on both these platforms. You learn about using a canvas in order to draw something on a custom image, create that, export that. So this is going to be super, super exciting here. Okay, so the project that I am in here is really a completely blank Compose Multiplatform project. And before I show you how you can create this yourself, maybe just two general definitions, because many people are quite curious about, okay, what is Compose Multiplatform? What is Kotlin Multiplatform? Are these the same? Can I only use one of these in my project? And it's important to understand that as the foundation before starting into this course here. First of all, Kotlin Multiplatform. Kotlin Multiplatform is really the fundamental technology that allows us to use Kotlin code and write Kotlin code, run this on multiple platforms, so Android, iOS, desktop, web. And doing so, writing code that runs on multiple platforms typically comes with a lot of shared code, with a lot of code that is actually the same, with a lot of logic that is the same between all these platforms. So for example, in our case, the dragging logic, how we want to transform these texts, that is identical on Android and iOS. And what Kotlin Multiplatform as a technology allows us is to now share this logic between Android and iOS. So we just need to define it once rather than twice, which we would have to do if we would build two separate native apps. Compose Multiplatform now is kind of an extension of Kotlin Multiplatform. And Compose Multiplatform just allows us to also share logic that involves the UI. So we can actually share the look of our app while defining that in JetBrains Compose in Kotlin language, and then it will look identical on all platforms. So you can use Kotlin Multiplatform without Compose Multiplatform, but you can't use Compose Multiplatform without Kotlin Multiplatform. And this distinction is important to understand here. But let's actually get here into Android Studio. That is the IDE that we will use here to build this project. First of all, as I mentioned, I'm in a very blank project. If you want to create such a project, then Android Studio nowadays has a built-in wizard. So you would go to File, New Project, and then here this New Project dialog will open. And here under Generic, you can create a Kotlin Multiplatform project. For this template here to appear, you would need the Kotlin Multiplatform Android Studio plugin, so that you can install in the Android Studio settings. But if you then double click on that, you can give your application a name, so your meme creator, whatever, select the package name. And other than that, we can really leave this as it is. Click Next. And here we can then select which platforms we actually want to support with this project. So definitely keep Android and iOS ticked. Also keep Share UI, because we want to use Compose Multiplatform. If you would say do not share UI, you would have to implement the UI natively for both platforms. So in JetBrains Compose for Android, since that is already the native UI framework on Android, but on iOS, you would need to implement this with, for example, Swift UI. So you'd write the same UI code kind of twice in different languages, which is not what we want. We want to use Compose here to define this once. So let's leave this at Share UI. We want to untick desktop and web, unless you want to extend this on your own to these platforms. And we also want to untick server. We're not going to need a server here. And we also won't get into any testing. So we can untick all these 4 boxes here. And then if you click Finish, you will end up with a project setup exactly like I am here. Now, before actually writing our first line of code, we need to import certain resources. So if we take a look at our final app again, and obviously here we have this meme, let's call it meme gallery screen, where we see all of our meme templates. And these meme templates our app, of course, has to know. Then there are now 2 ways to get these meme templates. Option number 1, that is the free option. You just download these from somewhere on the internet. For example, use the Image Flip website, which is a browser-based meme creator. You can just download these meme templates and then import these as resources here in Android Studio. That is what we will do. But maybe it's also worth mentioning that the Image Flip website has an official API, which you could use to really load these meme templates into your app. So here we, of course, a little bit limited with how many of these templates we have, since we we didn't want to download thousands of these images here and import these. I think those are roughly 50. But if you want to extend this, a cool extension would be to load these images from the image flip API. However, doing so is, I think, requires a paid plan for the API, like $10 a month. If that doesn't hurt you, I think it's a cool feature. Okay, but let's actually start importing all the resources that we need. What does that involve? Well, on the one hand, of course, these images, but that's not it. Here in common main, we have this compose resources folder, which is the folder for our shared resources. So for those resources we want to access in our common code, in the shared code. But we would also, for example, have Android-specific resources here that just exist for the Android side. So what do we need here? We need the templates, of course, as simple images. We need the fonts. So we have two different fonts here. I think this is called a Manrope, which you can also download from Google Fonts. And here in the meme creator, this is the typical meme font, which is called Impact. And both these types of fonts we need to import here in Android Studio in order to then also use these in our project in Compose UI. And something that I would also like to really copy paste here are our string resources. So all those different strings we somehow display in the app, because it's quite annoying to always create these on the fly in a Compose Multiplatform project, since that requires rebuilding to get these resources. So all kinds of strings that we display, like your memes, or I should actually say meme templates here, or add text, save meme, all these texts we will import as string resources here in this app. And also this color theme, so which specific colors we want to use in this app, the color combination and theme combination is also something I'm going to import. All those files that you need, so these templates and the fonts, probably attached to some kind of drive folder, or alternatively you can also download these from the GitHub repository, which I'll put down below. As usual in my videos, you will find a GitHub link down below where you can find not only the initial code for this project, but also the final state, in case you maybe run into some issues and you want to find out if you did something wrong. And in case you may be new here on this channel and you're interested in Kotlin, then of course subscribe, because I'm releasing 2 videos every single week about just Kotlin, doing nothing else for the past 7 years. So if that's something you want to make your career, then you're right here at this channel. So what I will start with is here under project in Compose Resources Drawable. This is the resource folder for all of our images, vector graphics, and so on. We have this default Compose Multiplatform XML file, which is a vector, which is always there in an initial project. But I want to paste all my resources that I've now copied over from my prepared project. Here you have all those meme templates as WebP images. So make sure to take these from the drive link that I will put below, download these, and simply import all those meme templates. You can see here's a sample template into the app, and we will then load these and display these in our initial meme gallery screen. However, as I mentioned, that is not it. We also want to go to Compose Resources, New Directory, and we want to create a font folder and also name it exactly like that, in which I will paste our 2 fonts. So simply the Impact TTF and Manrope TTF. We can open this here. You can see this is our font, also contained on the drive link. Probably just upload a zip file or so. And lastly, for our shared resources, let's collapse this. I want to create a new directory called values. This is technically for multiple types of resources, but in our case, we will use this for string resources, which would then also technically allow us to localize the app with different languages. Fairly easy. So if we paste this, those are all the strings that we may need in this app. I think this one, title your memes, we can change to something like meme templates. This is the first title that shows on the first screen. We initially had a little bit of a different vision with this app on the first screen, which we then migrated away from. So maybe not every single string here is exactly what we want, but it's a nice foundation that we can work with. So let's close this again. And next up, go into our theme definition. So our theme really defines which colors we want to typically use for common surfaces and common backgrounds and common text colors, for example, across the app. This is defined here. Actually, it's not defined anywhere. In a normal native Android project, there's typically a theme folder where we can define this, but here in Compose Multiplatform, there isn't. So if we open this app.kt file, this is actually the entry point for our application. So the very first composable that will show when we launch the app, regardless of Android or iOS. And here we have this material theme block, which surrounds all of our content the app will consist of. And all the content in here will be able to access those shared theme colors. So we have a very consistent look of our app. This, however, we want to configure a little bit. So we have this purplish look that I've shown you. So let's maybe I will create a theme folder here. Let's put it in core. So core.theme. Core is a package that I like to create for all the shared code between features. That's something, and how our architecture will look like, I will get a bit more into when we really write real code that isn't just about theming. So ignore this for now if this is new to you. But let's go into theme, and here we will define something like a theme KT file, so a theme, and then select file. And here for now, we can really just paste these different colors. So you can see we have different types of color tokens that we could use here and reference in our project. This is a dark color scheme, but if you would want to add a light theme here as well, then you would just add another block here with a light color scheme instead and define, okay, this is how this corresponding color would look like on a light theme variant. This in regards to the colors. We will also need to define our fonts with a theme. That I won't do yet, because there's one more thing that requires a little bit of copy pasting, and that is our dependencies. So the specific libraries we want and need for our project. So where do we define those libraries that we want to use, so those extensions of our project? Here under Gradle. So Gradle is our build system that really packages our project together into something that we can execute with all these different classes that may come from these library extensions. And here we have the so-called version catalog, this TOML file, in which we have all those declarations for different dependencies and libraries and versions that we may want to use in this project. And this is now something we want to extend a little bit. Actually, there aren't that many different libraries that we need here. I will still replace this here with my definition of our final libraries and go over that for a moment so you know what we'll actually use for what. So Kotlin version 2.2.20, that is the latest one at this point. AGP, so the Android Gradle plugin 8.13. In case throughout this video you run into any kinds of Gradle issues or so, it can make sense to play around with this plugin, and especially to also use the same versions that I'm using here. We have Kotlin serialization that will be necessary for navigation. So when we jump from one screen to another, from our meme gallery screen to the meme editor screen, and we need to pass certain data, this allows us to do this in a type-safe way. More about that later. Compose Multiplatform version 1.9.1. Some Android lifecycle, those are default dependencies. Coin, very important for dependency injection. So dependency injection is also something I'll explain a bit more in detail later, and why we have Coin as a library here and how it helps us. But it's the typical approach for dependency injection in a Kotlin multi-platform project. Coil will be, as you can see, for image loading, image caching. So whether you need to load images from the network or from some kind of URL, or just locally and need to make sure that accessing these images is fast, that you have a cache after all, then use something like Coil that helps you with that. Navigation Compose, that's the typical navigation library here for JetBrains Compose, also in Compose Multiplatform. There is nowadays Navigation 3, which is a newer navigation library from Google, but that at this point when I record this video does not yet support Kotlin Multiplatform, as they say it will in future. So those are all the libraries we use, specifically the versions, but here under libraries we can see all those specific library definitions where Gradle can see, okay, this is the actual idea of the library where you can fetch the necessary classes from that this library brings. And here at the end we have some Gradle plugins. So that's not about code that we can use in the project itself, but extensions for Gradle after all, for code generation, these kinds of things. For example, the serialization library here also comes with a plugin. And lastly, bundles here. We have some bundles that is optional, but you can bundle multiple dependencies you always want to apply as a whole. And then you just need to apply the bundle rather than all these specific dependencies here in Gradle. If we now click Synchronize Now, then hopefully we should not get any errors. And we do get errors because we've changed something. So build Gradle, this is now the root project file that has opened. And it complains about, hey, this unresolved reference actually doesn't exist. So previously, before swapping this out, there was a name Android application under the plugins block, but now it's actually called a little bit differently here with a dash. So we would need to swap this out with Android dot application. So these dashes actually become dots when adding these plugins and applying this here really in a Gradle file. Same thing for library, same thing for Compose Multiplatform, Compose Compiler, Kotlin Multiplatform. And we also want to duplicate this to also add our new plugin, the serialization one. So if we say Kotlin, what is it? Kotlin, not just serialization. Plugins serialization. And if we then synchronize this again and try this again here, we should not get any errors in this file. In another one we do, because here, this is now the Compose app Gradle file. So here in the Compose app root module in the green type of package here, we have this Gradle file. And this is now the Gradle file that is really specific to this module, so to our real project after all. And here we can now say these are really the plugins we want to apply. So while in this root file, we rather just define which plugins we generally have and we generally want to apply somewhere in this project. But then we have specific modules here in this project. In our case, just one. This is a single module architecture. But technically, you could have multiple modules, which would also serve as libraries on their own. That will be too much to get into here. For that, I have premium courses that teach this in detail. Also in Kotlin Multiplatform, by the way. So I recently just released a whole 56-hour KMP bundle, for which I also include a link in this video's description in case this interests you. But in the end, we want to just say we apply certain plugins here with the same type of naming as before. Same thing for the serialization plugin that I've added previously. If we now try this again, here we actually also have some unresolved implementations. Let's remove those errors for now, and then we will add what we need. Click try again. There we go. Now that sync was successful, we did not get any other errors. The last thing in regards to Gradle and these dependencies we need to do is we need to really add and implement those dependencies. So with this implementation block here, specifically those that we want to use in our real code, because before we do that, we won't be able to access these dependencies. Specifically, we do this here via implementation, and then we reference our version catalog here with ellipse, and then we have a type-safe way of accessing those dependencies and libraries we've added previously. So for example, Material 3 Adaptive for all kinds of adaptive UI functionality, which we can use to get information about screen sizes for responsive UI and so on. Same thing for adaptive.layout. We need libs, compose, UI, backhandler, and then we can apply our bundles that we've defined as well. So libs bundles this time. And here we have our compose, Android X, and coin bundle. So let's add all those. Compose UI, actually it's called. We have a coin bundle, coin common actually. So here we are in common main dependencies. So those are the dependencies we can use in our common main code. So all the shared code between these platforms. But as you can see, we also have platform-specific code bases here, or source sets, that is how it's called, where we will put Kotlin code that is exclusive to a specific platform like Android. But that's also something we will get into much more in detail later in this course when we really write such platform-specific code. Other than coin common, we want the lifecycle dependency, so Android X lifecycle. We want to add, let's put this up here, maybe the serialization dependency. So libs serialization, or is it Kotlin X serialization.json. So it will be serialized as JSON when navigating. We want to add coil, so our image caching library, coil compose specifically. And lastly, I think navigation, so which is JetBrains Compose.navigation. So these are the dependencies that really apply to our common code, as I mentioned. You also notice that there are some compose-specific dependencies pre-applied, which we didn't get from our version catalog. These come from the Compose Multiplatform Gradle plugin here. And in the end, add all the necessary Compose Multiplatform dependencies based on our Compose Multiplatform version that we've chosen for this plugin after all. So here, we really don't need to touch those. You don't need to update those manually and to reference different versions, but just by updating the Compose Multiplatform version, where is that? Here somewhere. Here, Compose Multiplatform. This will update the version of the Gradle plugin and therefore also update the version of all these related Compose dependencies. And one last thing we need to add here is an Android main, because there is an Android-specific coin dependency. So we can say implementation, libs, is it bundles, coin, Android. Because in Android, we have some specifics about the platform that require a specific dependency. Also more about that later. Don't worry if this is new to you at this point. After having added all those dependencies, I would say we synchronize this and hopefully don't get any errors. And that is looking really, really good. My sync was successful, and I would say this is really it for Gradle at this point, what we need to configure. And if there's really something missing, then we will just fix it on the fly later in this course. Maybe just to give you a little bit of an extra overview over this Gradle file here. We also have an Android block that gets generated. This just includes configuration just for the Android app specifically. So for example, we have something like a compile SDK, target SDK, so which specific Android versions you want to mainly target with this project, which minimum Android version is, for example, supported. These will be the places where you can change these details. This is important that you also have this, dependencies, debug implementation, compose UI tooling, because this will enable us to use the preview, the Compose Multiplatform preview here, so we can directly see in the IDE what kinds of UI components we build and how they look like. The same thing actually needs to be added here in Android main. This is already there in the initial template, so you should also have that. What I would say is we get into coding. Let's take a look and close all these things here. First of all, where do we start? I would say we start with our theme definition, since this is really the foundation of our UI. And in general, I'm a big fan of starting with the UI of an app, because it's a quite common question I get. Do I start with the UI? Do I start with the business logic, with the data layer? And I like starting with the UI layer because it immediately gives you visual results. You immediately see what you're building, whether you're on the right track. And without the UI, you would not be able to interact with the data layer. So if you would now start with a data layer definition, so how you make network calls, how you make DB queries, which won't be applicable in this project, but generally, if you would start with that side, you could, of course, implement that. Playing around with that and testing if what you've implemented really works is a bit more difficult, since you would need to make manual function calls, work a lot with print line statements that maybe print the contents of your DB or the API response. It can work, but it's just more annoying to work with that. However, if you start with the UI, which you will need anyways, and then get to the data layer, the moment you implement certain parts of your data layer, you can very easily already try this out, because you have the UI already in order to click a button, to make a network call, to make a DB query. You can immediately see if the list of items is correct. So it's a much nicer environment to experiment with what you're doing in the data layer if you have the UI set in stone, rather than starting off with the data layer. And the UI typically just starts with the theme definition. So on the one hand, we want to define our color scheme, which we've already done. But on the other hand, we want to define the fonts that we want to use. Let's put this in core theme. And we say, okay, we have a fonts file. And here what we now need to do is we need to load the fonts that we've added to our Compose resources font folder. And this may require a rebuild of this application. Let's first of all see if it does, or if maybe this already worked in the meantime. But in general, such Compose multi-platform resources are generated, so there are Kotlin-specific accessors generated when our project is being rebuilt. So let's first of all have an object that we call fonts, because we'll have multiple fonts. And in here, we can define our two font types. On the one hand, this manrobe font, which is a composable function, actually a composable getter, and that's equal to a font family. And then I'll enter here to import this composable. This may look a little bit weird with the syntax here because we have val and a composable. Let me first of all type this off, and then I'll explain what happens here. Font family, here we can now list all of our fonts that belong to this font family. In this case, it's just one, since we don't have different variants where it's maybe some variants are bold, italic, and so on. We just have one font type, so we can reference this and create this as a font. Specifically, we're going to use this overload that takes in a resource and not a res ID. This is the overload for Compose multi-platform. The resource now comes from res, so you can see that is the resource object generated by the Compose multi-platform plugin. And then here we can, for example, access our fonts. And you can see it is already generated. So manrobe, in case you don't see this manrobe, as I mentioned, just launch your app on Android or rebuild it normally. And then after that, you should be able to import this manrobe font. Additionally, you want to define the weight. So whether it's bold, light, or so. In this case, it's just font weight normal. The thing is, if we now leave out this composable annotation, then we can't access this font here, because this font, you can see, is a composable function, and therefore we need to also call it in a composable function. However, since this manrobe val doesn't need any parameters that we pass from our side to it in order to get this font, we can just make this a composable getter, because this getter is in the end a function that it gets executed the moment we read the value from this manrobe font. And since this getter is nothing else than a function that returns a single value, we can also annotate that with composable, and therefore use composable functions in there. So we don't need to make this a function, which would rather feel unnatural for a font. The same thing we can now copy and paste, do for the impact font. We just replace the manrobe font with impact. And this is now a global object we can access across the project in order to reference a certain font. Additionally, we want to define a typography object. The typography is in the end now similar to what we defined here as our theme, just in regards to fonts. So we have different types of text styles that we can define now and then reference in our app. So title large, title medium, display large for different types of text depending on where we want to show these. Also just to unify how our text look like across the app. For that, we say val typography is equal to typography from compose material 3. And here we also want to have a composable getter, which we set equal to a typography object here. And in this typography object, we can then define all these different font styles that we may want to use. For example, the display large text style, where we can say this is how display large fonts would look like in our app. So we can set the font family. This is also what really makes these fonts the default also for typical Material 3 UI components that are already there, since they under the hood reference these specific text styles. So we can say fonts dot manrope here for the display large font. We can define a default font weight for that. Font weight medium, for example. Font size 24 SP. And I'll define a line height of 28 SP. And this is in the end what we now want to do for all different types of text styles that we want to use in the app. I don't think I need to type this off here in the video. You find all these text styles, of course, in the GitHub repository that is linked below. So I'll just paste my remaining styles here. I need to, of course, fix those names a bit. Just remove the package name since it's copied over from my other project. But then these are the text styles that we want to use. And all of those, in this case, reference manrope, because the impact font will be referenced manually, since it's really just for our meme editor, and that doesn't really fit into such a text style. Now, lastly, in order to really use all those values in our theme and bundle this together, because right now you can see this is unused, just like our dark color scheme, we want to go to theme.kt and create a composable function called maybe meme creator theme, which is going to be the replacement for this wrapper composable here, where we currently just use the material theme composable. That is the one we now want to use in here. Specifically, we also want to reference the actual composable content that we want to show inside. So this will be what comes inside here. And in here, we then use our material theme composable, where we can reference a color scheme. Since in our case, we just have a dark theme variant, we can just link our dark color scheme. Shapes, technically, you could also create theme variants for different types of shapes, which we don't need here. But the typography parameter is something we want to pass, specifically our typography object from the other fonts file. Lastly, the composable content we can just forward here. And then in our app, instead of relying on this material theme, we can now rely on our meme creator theme. And now everything in here will use our typographies and the colors that we've defined. So this means if we already launch this app possibly and take a look here, then we should see a more purplish color scheme for this initial code, because there is a button already, there is a color animated visibility with an image. It won't look like this yet, but we should see something already. And there we go. You can see, looks a little bit weird right now due to these color definitions, but this is definitely not the default look. So that means our material colors are definitely being applied. We can click this here to also see this animated visibility thing here. Of course, this is not how our app will keep looking like. So I'd say the next step in our app is to really define our meme gallery screen, which is actually not really a very difficult screen. We don't even need a view model there, since if we think about it in the other app here, this list of memes is actually a completely static list. It's not any type of state, so a value that could really change over time, where we load this from the API. We don't know it at the point of initializing the screen yet. No, it's a completely static list that is always the same and always comes from our local resources. And if we have a static list that can't change at any time in the app, we don't need to make that a state. And other than the static list here, there really aren't any other values on the screen that can change. So we don't need a view model. Don't overcomplicate your UI or your screens and your app in that case. If you don't need something, then leave it away. And for those of you who are maybe not sure what a view model is in Compose, that is in the end just typically the kind of the brain of your UI, which receives certain UI actions. So what the user does on the screen, clicking a button, entering some text, then processes these actions internally, decides about, okay, what needs to change on the UI? Maybe you need to show a loading indicator. Maybe I need to update a certain text. And these changes, it then kind of sends back to the UI in form of a state update, which the UI can then just show in the UI. So the real logic that powers how your UI looks like, that would normally go in a view model, and we will also work with a view model in this project for the editor, but not for this screen. So I would say, let's go to our project view. And maybe at this point, I need to start talking a bit about architecture, because even though there's a very small project, it could be that at some point you want to extend this project. So it definitely makes sense to think about how you structure the project so that extensions later on of this project are rather straightforward, so that it's more or less intuitive where to put new code and how that integrates into your existing product structure, especially when you're working in a team, that everyone knows, okay, here's a new feature and this is how this new feature needs to be integrated, so that everyone is on track with that and knows where to also find things and understand things. And while there are a gazillion ways to implement architecture and also a gazillion ways that are fine, how I typically approach architecture in my projects is, you've already seen the core package, but let me first of all create something like a meme gallery package. So now we will in the end think of distinct features of our app. So really distinct isolated parts that could technically also have a value alone outside of our app in a different context, in a different type of app, and then put just the code into these packages that is needed for that feature. And specifically that code, we further divide into clear layers. So clear responsibilities for a specific part of the app, where we say, okay, one responsibility would be the UI part of a feature. One responsibility would be the data part, so where communication in the end leaves the app. So talking to a DB, to a remote API, talking to a system API, like, I don't know, getting sensor data from Android or iOS. In our case, talking to the file system as well, where we need to export something. And optionally, you can also stick to an additional domain layer, which is then for the business side of things, so where you will really implement the business logic. So you take the requirements from the real world kind of and the rules that you don't implicitly know from your app and implement them in code. That is a bit difficult to understand, but what such business rules and business logic could be is, for example, you have an app with different types of users, where you have normal users, moderators, and admins. Those are, first of all, external concepts that you have to somehow implement in the app, but how these users are in relation to each other and which user is maybe allowed to do what, that is something that possibly your client would tell you, where they say, hey, the admins are allowed to delete the entire accounts. Moderators are allowed to edit posts. Normal users are not allowed to edit posts. All those are so-called business rules. So something that you as a developer can't implicitly know, because it just originates directly from the business and the domain of the app. So which problem it really solves. And how these single business rules are in the end connected and interact with each other. So the actual logic that implements these, that is then the business logic. And all that would go in your domain layer, which, as the name says, is really about the domain of your app. I will say right away, this is a quite simple project in regards to architecture, and we would really not need a domain layer here. There won't be any real business logic in this case, since most of our logic will be in the UI and the export feature, and none of that is business logic. I will still work with a domain layer here in order to teach you a bit about these architectural principles and why this can make sense in larger projects, but it's really not something you absolutely have to stick to. In this meme gallery feature specifically, we actually only will need a presentation layer, so the layer that will contain our real app's UI, so the composables, possibly view models, but as I mentioned, for the meme gallery, we won't have view models. So we should also just work with this presentation layer. We will have a further split here for the next feature we will talk about, which is the, let's call it meme editor feature. And in here, we can now also have a presentation layer for the UI of that meme editor. We will have a data layer for the data side of the meme editors. And in the meme editor, we need to export certain things. We need to export our images, maybe share those. And technically, we could also have a domain layer here, which you will see later how this can be useful, but it won't be very large for this feature. So now we divide our project here into distinct features. And it's important to understand, a feature is not necessarily one screen in your app. In this case, I would say it is. However, actually not necessarily. So you could also completely say that the feature consists of these two screens together. Because a very valid argument would be that you say, okay, how would I use a meme gallery with empty memes without actually being able to edit those memes? Is this actually really a distinct part of the app? So you can see this is really not black and white here what a feature is. And very, very often I would say that if you have a list and a detail screen in an app, these two screens belong to one feature, since how would there be any value of a detail screen if there would not be a list screen from where you could get to those details? However, if in addition you would, for example, have a login screen and a registration screen, then login and registration together could be another feature, since a login and registration functionality is something that is completely isolated of the rest of the app. It could be a social media app that this could be useful for. It could be some kind of chatting app that a login and registration feature could be useful for. So when it comes about thinking how to split your app down into features, it's really about thinking which parts you could really use in isolation in other projects as well for them to make some sort of sense. So really debatable here whether we want to put these together in one feature or leave them separate, as I will here. I would argue, okay, the meme editor could possibly become a quite complex part of the project, especially if you would extend it with selecting different text colors, also adding images to memes and dragging these around. And I would say, okay, maybe you would want to have such a meme editor in another meme app where you don't select meme templates, but maybe get these somehow else. And then you would not need this meme editor together with this meme gallery. But completely debatable, and whatever you stick to is fine here. However, what you will notice is when you work with this type of architecture, there will sometimes be classes, functions, files that you need to access in multiple features. So both in meme editor and meme gallery. And for that, we have our core package. So core really consists of the core of our app. You can also call it common, for example, which may be a bit clearer here. But that includes classes and functions that really shared and can be shared across features. However, everything that we put in meme editor in any of these packages should not be accessible by meme gallery and vice versa. So this way we already have quite a good distinction and isolation of different parts of our project. And if you want to take this to the next level, then you could really implement those features as really a Gradle module. So it's really isolated, fully isolated parts of the project, so that you really treat those as libraries that you could also use them to easily include them in other projects. But that's something I teach in my Kotlin Full-Stack Developer Bundle, link below. I would say we now jump into meme gallery, presentation, and we start building our UI. So a new Kotlin file, and we're going to call this meme gallery screen. Make this a file, composable, meme gallery screen. And what will the screen actually need? It will need a lambda, a callback lambda, that triggers when we actually select a meme. Because when the user selects a meme, then we want to navigate as a result of that. So we want to take this meme template and navigate to the meme editor while passing in this meme template that was selected. So we could have a lambda on meme template selected, and well, we somehow need to pass this meme template. So which particular image we've clicked on. So we have lots of these WebP images, but we somehow need to pass this information to the editor screen. For that, what I would like to do is I would like to create a little helper class, I would say in actually not meme gallery, but also not meme editor, because if we think about it, we have a meme template class. What should this class bundle? It should in the end bundle just which resource ID, so the actual name of the resource, and the actual underlying resource we want to pass from screen to screen. And here we already said it. We need to pass this from screen to screen, and therefore both our screens and packages therefore have to know this class. So it should rather go in core presentation, so into the section of our code base where we have all the shared code, or the UI-related shared code in this case. And here we say we create a meme template class, specifically a data class, which will have an ID, so simply the string of the resource name, as well as the real drawable behind that. So a drawable resource. And then we can have a static list here. As I mentioned, this is completely static. We can load this at the moment our app boots up. We simply have a list for our meme templates, and we just need to use resources here, res.drawable, and not just drawable, but all drawable resources. So a very cool thing that Compose Multiplatform resources offer us here, which the normal Android resources don't. We get a map of string to drawable resource. So this will be a map of all of our drawable resources. And when passing in a key, so a specific ID, so meme template 42, for example, then we get the corresponding drawable resource. And this is something we can easily now filter. So we could say filter keys, because we want to only have our meme template resources in here, of course, and not any other resources, which would also be included in the map here, like I can save or Compose Multiplatform. So we can say we filter those keys for all of those that start with meme_template. So this will now be a new map that just includes our meme template resources. And with this new map, we can map all these entries, so key value pairs, to our meme template classes. So we say meme template ID is simply the key of the resource, and the drawable is the value. And now we suddenly have a list of meme templates, bundles all this data for us. So it means in our gallery screen, here as a callback, we can provide a meme template that we've clicked on, and that will be very handy. And also if we then extend our resources here with, let's say, meme template 53, this will automatically be included the moment we add this, since we have this dynamic mapping approach here with these meme templates. Let's go in here, and we have a scaffold as a root element. A scaffold is just really nice as a root element to consider typical window insets, so these extra spacings that come from system components like the status bar, like the notification bar, the navigation bar with the navigation action, so that our content or the interactable content doesn't overlap with that. First of all, what we want here is, let's have a piece of content that gives us this inner padding we need to add, which considers those window insets. And I would like to add a top bar, so specifically a toolbar, because here you can see in our prepared app, we have a toolbar with a text, and then we have our list or grid below. Here we can simply use a top app bar composable, give it a title, which is simply a text composable, and the text can be string resource, res, string, and this would be meme templates. Then I would say we leave it like that. It will look slightly different than here, but I think this text is a bit too large here on this end. So let's just opt into this meme galleries, into this experimental API here for this meme gallery screen KT. So that is experimental. Just need to add this annotation here at the top, so we get rid of the warning. Inside the scaffold, here we will now put our real content. And what kind of content will this be? This will be a so-called lazy staggered grid. And this creates a pretty cool look, especially if you have many list items that have differing dimensions, like these images here, or those all have different types of aspect ratios. And we get this very cool grid look. Also, if we then rotate this, this is responsive by nature. So you can see we then suddenly have 5 columns for all those templates. And the same would, of course, apply on a tablet layout. That we would get more of these templates here and more columns. This is super easy to apply. We just would need to say we have a lazy vertical staggered grid. So we want to scroll vertically, where the columns are equal to staggered grid cells dot, and here we have different options. Fixed would be we can provide a fixed number. So we always want to have 2 columns, for example, independent of the screen width. Not really what we want here. We instead want adaptive, where we can pass in a min size. And I will choose 150 dp here. So what this will do is it will always make sure that every single element, every single grid item will at least be 150 dp wide. But based on that, it will try to fill in as many of those elements in a horizontal fashion as it can. So if this screen here is, for example, 400 dp wide, it tries to fit into the first one. Okay, so we have 250 dp remaining, tries to fit in the second one. We have 100 dp remaining. Then it notices, okay, a third one doesn't fit because every single item must be 150 dp wide at least. So instead of then giving those items 150 dp as the min width, since there would still be 100 dp missing in that entire available width, it will instead make them span the available space. And that's what adaptive will do, and exactly what we'll need here. We can then also add this little spacing here horizontally and vertically between these items. Horizontally, that works with horizontal arrangement, and we're setting this to arrangement spaced by, for example, 16 dp. We can also set a vertical item spacing of 16 dp. We can add some content padding, so this will be the padding around this entire grid. Here, we want to use our inner padding, so the padding values on the one hand that we got from the scaffold. I'm not sure if we can add another set of padding values here, where we say, okay, we want to have, let's say, 8 dp of extra spacing in addition to those window insets. I guess that should work. So we now open a block for the content. No, it doesn't work. Okay. Then let's do it like this. We get rid of the inner padding, and instead we say, okay, here we pass in the inner padding dot. Okay, then let's instead do it like this. A little bit more code, but seems to be necessary. So we have our normal padding values and we create those, but we now say start padding is inner padding, calculate start padding, or let's actually say calculate left padding, layout direction here from compose UI unit dot LTR, and then we can do the same for the end padding. Here we have the calculate right padding, and same for top and bottom. So here we want to say calculate top padding plus 8 dp and bottom will be calculate bottom padding plus ATP, like this. So now we have just the window inset values combined with our own additional ATP of spacing. Now inside here, we can have an items block, which means we can define how each grid item will look like. So we will use this overload that takes in a list, and the list will just be our meme templates. So the static list that we've created over here. We can then also give each item a key, which can help Compose to optimize recompositions when something changes. Here, nothing really changes, but we can still do this fairly easily by taking a look at the item. Wait, let's extend this first. And then we have it.id, just something that is always unique about a specific item, which the ID certainly is. And then we get each meme template here in this list, and we can decide how we want to render this meme template. For example, with an image composable that takes in a painter, and with a painter, we can create a painter resource. We may actually also want to put this in a card layout with a bit of elevation and shadow therefore. So let's on the one hand say we have an on-click lambda where we say on meme template selected. We pass this meme template here that we've clicked on. And we may also want to give this some elevation, card elevation, card defaults actually. Card elevation. And we say the default elevation is 4 dp. And then we can open this block of code here. A card by default has these rounded corners, which looks very cool, I think. And in here, the content of this card will simply be this image, and the painter resource now comes from our meme template, .drawable. The content scale can be content scale.fill width. So what this will do is it will always make sure to make the template fill the available width, so exactly the width of this color we place it in, and then evenly extending the height of it. That is what gives us this staggered grid look, so that some of these elements are of a taller height than others. Additionally, we also need to say we give this a modifier, so we really make it fill the maximum width. And lastly, a content description of null. So we don't need to pass a content description here for those memes. Otherwise, you would need to have some kind of text that describe which meme you are currently creating. But I would say we actually take this screen and go to our app KT composable and already add this here. So we can already try this out if it looks as on our left side. So here, let's have a meme gallery screen where we have an on meme template selected, where we get the meme template if we click on it. Let's leave this blank for now, but launch this already here on our Android device. There we go, it's launching, and this looks pretty much like before, just that our text here is a little bit smaller, but that is intentional, as I mentioned. And we have all of our meme templates in here. And you can see we get this hover animation here. We can click on those. Right now, nothing happens, of course. But that's already our first screen. You can see this was a super, super simple one. We did not even need some kind of state, or there isn't really much that the user could do on the screen or that could change. But the moment we now click on that, we of course want to get to the meme editor, which is going to be the biggest feature here of this app, of course. So what comes next in this app? Obviously the meme editor, but breaking this a bit more down into smaller parts, I would say we first of all create what I will call the screen skeleton of the meme editor. So this means really just the necessary classes, how the screen is wired together in the end. So a UI together with the state, so with all the values that could change here over time, with whatever the user could do in the UI that could lead to a state update. And of course, the core empty at this point view model for the meme editor. So that we just have something that exists that we could then also navigate to. That will be the next step after that we implement our navigation setup so that we really respond to triggers of this Lambda and we really perform a navigation action to the meme editor when having selected a meme, since that will be necessary in order to then also test this feature later. And for creating this initial screen skeleton, I actually created my own template, a multi-file template. Unless you have added that and watched this video from me yourself, you won't have this template, but you can get and download this template from the video in which I've explained that, which I'll link down below. It will save you a lot of time if you stick to the same type of architecture as I will here. To maybe show you this very quickly here in presentation, that's where we want to create the UI part for the meme editor. We right click, and then here I have this compose UI screen with view model, which is, as I mentioned, custom template I've created. And here we really just need to give it a name like meme editor, click OK, and suddenly 4 files will be created here in exactly the schema that I typically use. So on the one hand, we need to import preview here and our, call it just meme creators theme. And then if we optimize those inputs a little bit, this has saved us so much typing. And I'll of course also go over these different parts of what this template has brought us here in a moment. But you can see we also got a meme editor action seal interface. We got a meme editor state with the 2 sample parameters. And we got a meme editor view model with all the boilerplate code about loading initial data. I'll also share something about that in a moment. But also an on-action lambda that receives our UI actions. So you have 2 options. Either you type this off by hand, or actually 3 options. You can type this off by hand. You can copy over the initial code from GitHub, or at least the code that you need here. I'm not sure if I will make an initial repo. And third, you take a look at the other video, download the template. In this video, I show how you can include it in Android Studio, and you use it for yourself for all kinds of future screens you will create as a mobile developer. Okay, let's first of all understand what this template brought us and why we will have those 4 types of classes. This is in the end typical MVI pattern fashion. So these typical MVVM, MVI patterns just tell us how we separate our presentation layer into distinct responsibilities. And in our approach, we on the one hand have a state. This is in the end a data class that consists of all those values that could change on that screen and have an impact on the look of our UI. For example, which texts we've already added and where these texts are, how these are rotated, whether our share sheet dialog is open. These kinds of things that can change over time and have an impact on the look of our UI will belong here in this state. The counterpart to that is this action seal interface. So here we define all kinds of different actions a user could perform. So simple triggers like clicking a button, or like dragging a text around, rotating a text. All these types of actions that we want to notify our view model about, that could then again lead to some kind of state update in some sense. This is what we bundle here. The big advantage of having bundled this here is that if we take a look in the meme editor screen, we just need to pass 2 values down to this actual composable, despite even if our state and action seal interface grows. So even if we would have 100 different state fields and 100 different user actions, we would still only need to pass 2 parameters down to the screen. And this is just a really, really big advantage here in Compose, since we don't want to pass down our real view model instance here, since that would typically be created from your DI framework, in this case Coin. And this can very quickly make the preview break, since this view model function, or in our case Coin view model, will not work in the preview, since Coin is not initialized there. And since we would very much like to preview our screen, we need to think of a way to actually just pass down values that could still make us mutate and decide about how this preview should look like and what it should preview, decouple this from the actual view model logic. And this is a very, very nice approach to do this, because here in the preview, we just construct our own state and we say, okay, is loading is true in order to preview the loading state in our preview. That's how easy this can work. Now let's first of all start to write our state data class and think about which values could really change here in our UI. So let's move back to the actual final app. Oh, come on. Final app. And let's say we go inside of the meme editor. And now let's think about what can really change here on the screen. On the one hand, what you've maybe already noticed, if we go back after having edited some text, then we get this leave editor dialog here where we just need to confirm this, that we really want to drop these changes or not maybe make another export. That's one thing that can change. So whether the dialog here is visible or not. Another thing that can change is here, if you take a look at this text field, there's actually a selection state of this text field where we can then also remove this text again, but also just see which text we're currently looking at. So there is a selected state of this text field. There is an unselected text when we tap outside, and there is a text state where we're currently editing that text and where we can really type something here. So this selection state is definitely part of the state, not only the general selection state, but the selection state per text field, or rather, at least a state that gives us the text field that is currently selected, if one is selected, because we can only select one at a time. We of course need some sort of state here for these texts that we can drag around, because this will also then make sure that these won't be gone or won't be in an incorrect position when we rotate the device, for example. Yeah, in this case, you still may need to adjust this a little bit, because obviously we have less space for the meme, but still we want all our text to still be there if we rotate our device or the screen size changes in some way. And finally, what we need to know is the actual size of the template, because this will be involved a lot into our final calculations for the export, for determining where our text actually is, but more about that later. Let's actually go here in our meme editor state and first of all define this template size. which is simply an integer size, so a pair of width and height values. And this can initially be 0, since we need to update that from the UI where we know this information. Then another easy state is leaving without saving, so which is just what our leave dialog should show. And then we need a little bit of an helper class or helper sealed interface. Specifically, what I will call this is text box interaction state. So this will be the sealed interface that will outline all those 3 different selection states that could be true at a given point. So either no text is selected, or a text is selected and then also contain the information which text is selected, or a text is currently being edited. That is the 3rd state. And these different states we outline here in the sealed interface by saying data object none, which would mean no box is selected, a data class selected, which means we've just clicked once on a box. We say which text box ID, so each text box will in the end get an ID that we can then use to find this text box in our list. And lastly, editing. So if we really are in the edited state for which we need to double tap. And here we also want to know which text box is being edited. And this we can then also include in our state here. So text box interaction state is text box interaction state, and the default is simply none. And lastly, we want to know our meme texts and specifically where those are. For that, I actually want to put this in a separate model class here in presentation. This is purely a UI-related model, so this doesn't belong in any other layer, since it also contains quite UI-related properties like where the text is. This is something that is completely irrelevant for the rest of our project, for data or domain. Actually, for data, it's not, but for data, we will just pass those values in a different way, since for the export, we do need to know that. But let's go meme editor presentation and have a meme text, which will be a data class. And each meme text will consist of an ID in form of a string. It will, of course, consist of the text itself that we've written on that meme text. A font size, which I will put as a float here, and I will default this to 36 as a font size. And now we, of course, need those transform values. And with a transform, I mean, on the one hand, the translation, so where this is, how it's offset. I mean the rotation, so we can, of course, rotate this, and we need to keep this value. And we can scale it, as you can see. And these values are, of course, specific to each meme text individually. So on the one hand, we want to have an offset ratio x, which is initially 0f, an offset ratio y. Here it's very important that we don't choose absolute values, so absolute offsets, how much this is offset from the top left corner, for example, by how many pixels, because the moment we rotate this device, then these absolute values will be broken. Since here we have completely different absolute offsets, so we want to make sure that we work with a relative offset. So we say, okay, here this text is maybe offset by maybe roughly 30% on the x and also maybe 30% on the y-axis. And since these ratios stay the same, we can then also calculate the new absolute offset when having rotated the device. We also want to say we pass in our rotation in form of degrees. Initially, we did not rotate this at all, so we pass in 0. And the scale, which is a float value, which is initially 1. Whoops, 1. And then in our meme editor state, we can simply have a list of our meme texts that have been added to that meme. So a list of meme text, and that's initially empty because initially we did not add any text yet. The same thing we now need to do for the other way, that we go in our meme editor action, and we add all those things that are in the end something the user did in the UI that we need to know about in the view model in order to change something about those values. For example, a data object on go back, so when the user clicks on this back button. Then we want to know about that since we need to show the dialog. So this would be a meme editor action. For example, on confirm leave without saving. So when we click here and we then click on leave, that's another action. Same thing when we cancel this, or on dismiss maybe. On dismiss leave without saving. Then we want to have a data object. Actually, make this a data class on save meme click, where we simply pass in the template. We could technically also retrieve this in the view model, but this is, I think, easier here since we already have this information in the UI. We want to have a data object on how do we say, on tab outside selected text. This will make us clear the focus. We will have a data object on add text click to add a new text. Data class on select meme text. So when we click on an existing text, which will give us text box ID, so we can also update the selection state of that one. We will have a data class onEdit meme text, also passing in the ID. So this will set the editing state for that one. Then we have a data class on meme text change. So when we really type something, this is just about entering the edit state, and this is about really changing the text. Here we have not only the ID for which text field this changes, but also the actual new text that we want to type here. Meme edit action. We have the option to actually delete a meme text. So on delete meme text click, also passing in the ID, which one we've deleted, meme editor action. Then what can of course change is the transform of a specific text. So we have a data class on meme text transform change. We want to know for which ID this has changed. We want to know the new offset. So this can now be a normal offset from Compose. So offset just consists of an X and a Y value. We want to pass in the rotation in form of a float, since that may also have changed, and the scale in form of a float value. And with that information, we can then update the transform for that particular text with that ID. And one last thing that can change on the UI side that the view model needs to know about, which isn't necessarily something that originates from user action, but still something we care about, is when the container size changes. So the meme template size, since that is information we need to use in order to update this template size here. So on container size change, and we pass in the new size in form of an int size. And we say that's a meme editor action. And that's really now our entire CL interface for everything that can happen here on the meme editor screen. Maybe something worth mentioning here, which you may have noticed, it makes a lot of sense to name these actions just based on what happened. So this may really sound like a detail to say on go back click, on confirm leave without saving, because we could also call this confirm leave without saving, or go back, or tap outside, or save meme. But by naming these actions, for example, this one here, save meme, rather than on save meme click, the UI would implicitly know about what happens as a result of the user doing something. And ideally, this information should be decoupled. The UI should really just knows what happened. The user clicked the button, the user entered something in the text field, and the view model is then responsible for deciding what happens as a result of that. Because if you would now call this save meme here, and at some point, saving a meme maybe has certain other side effects other than just saving the meme, you would either have to rename this action to also let the UI know about that more happens here, and it's not just about saving the meme, or you would have certain inaccuracies here, since the UI would still just think, okay, we saved the meme, but actually more than that happens. So that is why I really like this approach of just phrasing these actions in a way that they don't include information about what happens as a result of those actions in the view model, but rather just what happened in the UI. And the view model is then the brain of the UI, as I mentioned, which takes a look at, okay, the back button was clicked. This means this certain part of the state has to change. All right, so now we have this action CL interface in our meme editor view model. That means we can go in on action. This is now the primary function we use from the view model to let it know about something that has changed. We can go inside this when branch, alt enter, and add those remaining branches here. So we add all those branches, and here we can then consider all those actions that the UI has sent to the view model, and we can unwrap these here in order to then update our state. For example, a very easy one would be on container size change. Here we could say update container size, create a function, and we pass in the new size that hit alt enter here to create this function in the view model. It doesn't return anything. And we then say we update our state, so state.update, and we say we create a copy of this state and update the template size with a new size. And therefore we have this updated information in the view model and in our state. Okay, as I mentioned, I would like to go on with our navigation setup. All this here is something that we will get to when working closer with this actual editor logic here. But let's start with the navigation setup so we are actually able to get to the meme editor screen in the first place and be able to see the selected meme there. Navigation is something that is not specific to any feature, but rather something we could put in core presentation, something like navigation route, simply a composable. Make this a file, composable, navigation route. I don't think we need a modifier here, because in the end, this will really just contain our so-called nav host. So the nav host is, in the end, the root composable of the navigation compose library, in which we define which specific screens we have in the app and how we want to navigate between these. In order to implement that, we not only need this nav host, which you can see here, which takes in this nav host controller. So we can already use this and define this nav controller here by saying remember nav controller. And then we can, of course, pass this in here, nav controller. But now we actually need to define a start destination. So we need to have a set of screens that the user could end up on. In modern navigation, Compose works with type-safe navigation. So we define those different routes. So the screens, after all, in a normal Kotlin class or object that we can then use to also define which parameters we want to be able to pass between different routes. This works, for example, like this. In core presentation, we define a routes object, probably. Let's make this an object, and in here we would then, for example, have data object for our meme gallery. Let's actually make this a sealed interface, not a non-object, because this way we can limit the available options to just what we have inside this interface here. So we say that is of type routes, maybe just route singular, because we're always talking about one route specifically. This needs to be serializable. So we're going to have serializable as notation. Alt-Enter here to import this, because this is necessary in order to let Navigation Compose serialize this route object or class into something that can then be passed around between screens. If we now have a route that takes in a parameter, we need to make this a data class instead. So for example, our meme editor route. Here we want to say we want to pass in the template ID of our meme template that we've selected. So we can't pass real drawable routes here or drawable resources via navigation parameters. That is why we need to pass the ID, so something that is easily serializable. And then we can take this ID and extract the real resource on the meme editor screen again. Let's make this a route and also annotate this with serializable. In this way, we have a very central place where we define these routes, which are arguments they need, and therefore we can go back to navigation route and then say the start destination is now in this case meme gallery. And then we can open a block of code here in which we now define which screens we want to have in this app. This works with a composable block. So I want to have this composable, and then here as a generic argument, we need to now say which route this composable represents. In our case, meme gallery, first of all. On the other hand, we'll have another composable for our route meme editor. And in these blocks here, we can now put composable content that will show when we are on that corresponding route. And if you want to switch routes, we use this nav controller object to say, hey, now navigate to the meme editor, for example. So here we could, for example, put our gallery, a meme gallery screen, and then we can now respond to this on meme template selected lambda, where we get the meme template, and we can then say nav controller, and we want to navigate to a route here, and the route will be our route dot meme editor. And here we now need to pass in the template ID. So specifically, the ID from the meme template that we've passed here to our lambda when we've clicked on one. And it's also very important to know that this nav controller should not be passed down to such composables. I mean, technically we could do that. We could pass this here as a parameter to this gallery screen, therefore call the navigate function in the gallery screen directly. But this way, the meme gallery screen would implicitly know about other screens of our project, since it would know how to navigate between screens or features. And we want to keep our different parts of the project or different features as isolated as possible so that we could also use them in other projects, right? However, if our meme gallery screen must navigate to a meme editor, it's not isolated anymore. And these screens would have to be used together in that case. That is why for navigation, only this composable here should be responsible where the nav controller is, and it should not leave this composable in any way. For the meme editor screen, we can now use our meme editor screen composable that we get from our multi-file template. The state, actually no, it's not the screen, sorry, but it's the root composable, because didn't get to go over that, because we of course want to have our view model and get the state from that. But this root composable is really just for the entry point to get the view model, to initialize it from coin, to observe the state, but then just pass this down to the real UI. So this is the place where we put our real screens UI. This is the composable that would also be previewable, which is why it is contained here in the preview. But in our navhouse, we of course need to use this composable since we want to use the real coin view model in our real executed app. Back to navigation route. This, I think, is really it for now. If we run this now, of course, after having added this navigation route here to our app composable instead of the meme gallery screen directly, so navigation route, well, then this would generally add what we need, but you've just seen it in our meme editor. We get a warning here, and you maybe don't get that because you don't have the coin plugin installed. But the Coin plugin in Android Studio in the end tells you when a type is not declared in a Coin module. And now we slowly get to a dependency injection, which may or may not be new to you. But in the end, the idea is really that in our project, we have a bunch of so-called dependencies. With that, I really don't mean the dependencies that I've talked about in Gradle. Those are also called dependencies. But with dependencies in our code, we really just mean instances of classes. So for example, this meme editor view model would be a dependency of this meme editor root composable, because this composable depends on this dependency. That is where the name comes from. And now what we could of course do is we could also move this line here directly into the composable, which would also work, which would also give us the right composable and the right view model. But now the dependencies of the view model instance is not really being injected anymore. So dependency injection means we take such an instance of an object and we pass it somewhere as a parameter or as a normal constructor argument. Because when passing such dependencies, this gives us more flexibility, since whoever calls this composable can decide about which specific version of this view model it wants to use. And especially if this view model would be something like an interface, then there may be multiple different variants of that interface, multiple different implementations. And if you don't pass such dependencies as a parameter, there is no way for you to swap these out on a conditional basis. And that's really the core idea of dependency injection. You can imagine in a bigger growing project, you will have a lot of different classes in your project, be it view models, be it repositories, be it some kind of file export classes, whatever kinds of classes you need to use. And the more this grows and the more all these different classes somehow depend on each other, the more you just need to plan this a little bit, and the more you need a central place after all to manage these dependencies. So where different instances of classes are created in your project, from where these can then be injected all over the place. And that is something that dependency injection libraries like Coin really help us with. And Kotlin Multiplatform Coin is really the typical approach to do this, since it's a pure Kotlin library, and in KMP, at least in the shared code, we can only use plain Kotlin libraries that support Kotlin Multiplatform. So we can, for example, use Java libraries here as it would be possible on Android. So therefore, Coin is the typical pick. In order to now work with Coin, we need to set this up a little bit. And for that, I typically create another root package called di for dependency injection, in which we create something like an app module. So an app module, or rather just a module in regards to dependency injection, is really nothing else than a container of dependencies. So where we declare, hey Coin, these are the different classes that we need to pass around somewhere in the project, and here's how to create those. So we can define something like the app module, say that's a module that now comes from the Coin library, and we can then either define something like a singleton, so a dependency or an object that lives as long as the application does, and there's also only one instance of that. We could define a view model dependency specifically. So in our case, we could do this here with a meme editor view model. And by using these double colons here, this really just tells Coin to try to look up certain constructor arguments, which we don't yet have, but will have later. And as long as Coin can find definitions of these dependencies that the view model will later depend on, it will automatically wire this together. And it could be that we need to import this here first. So let's remove these double colons. No, apparently not. It's view model off. Sorry. Let's leave this as it is. And we say view model off. And then this overload will satisfy that. And the moment we just declare such a dependency here in a Coin module, Coin knows how to create these, given that it also knows how to create all the dependencies needed to create this view model in this case. In our case, right now, there is no constructor, so it can just create this out of the box. But right now, this app module is unused and nothing would happen here. In order to link this to Coin, we need to initialize Coin. And this initialization should happen at each platform's specific entry point. So simply place in our code that is executed exactly once when the application boots up. On Android, that is the so-called application class. So here in Compose app Android main, this is now where we need to initialize that. So this is now just Android specific code. And here we want to create something like a meme creator application. So this is now really native Android code that we type here, but well, obviously we can't share this now with iOS. If we create this meme creator application and we make this inherit from application, then we can go inside here and override this onCreate function. Because this is the function that gets called the moment an Android application boots up, and it will only be called once per lifetime of the application. And in here we can now say, we initialize Coin. But since this initialization of coin has certain parts that are the same between all platforms, between iOS and Android, for example, that on both these platforms, we want to link this shared app module here to coin. Because that's the case, we can write a little helper function in this DI package called initCoin, for example, make this a file. And here we have an initCoin top-level function, which gets passed a coin config of type coin app declaration. This is really nothing else than type alias for a lambda. So if we command click into that or just hover over it, you can see this is just a lambda that extends coin application that we can rely on here in order to then be a bit more flexible in configuring this from the outside. You'll see in a moment what this means. But inside here, we want to call start coin. That is what starts coin as a dependency injection framework and initializes it. And here we can then say config.invoke. So we just call this config with this. So this is the coin application we get from this lambda. And on the other hand, we want to link multiple or one module where we want to pass our app module. Now this function needs to be called from each platform-specific entry point. Because the entry point differs from platform to platform, that belongs in each platform's specific source set. So here, as I mentioned, meme creator application. Here we now want to say initCoin, because from Android main, even though we are on the native Android side here kind of, we can of course still access code that we've put in common main. That is really the whole purpose and point of Kotlin multiplatform, that we can do this, that we have a part in our code base where we can write native code for just what we need and want, and we still have a part where we can write all the shared code that is really identical across all platforms. Very cool. So initCoin, we call this, and now we can pass a lambda here in order to add further config that in this case may just be Android specific. For example, on Android, what we typically have is an object that is called a context. So context on Android it's very difficult to understand, but it's in the end something that bridges the communication between your app and the system. So the context on Android is, for example, needed to get access to system APIs, to get access to the resources and read certain files in, get access to the file system, these kinds of things. So it's really just a bridge. And on Android, there are different types of contexts. The application is one of them. So here we can simply say Android context, and we link this meme creator application here. So coin knows where this application context comes from, because on Android typically, or very often at least, dependencies need this application context in order to be created. So as soon as now a class, an Android specific class, requires and relies on this application context, coin knows how to pass this around because we've instructed it. This is where this comes from. Take the context from this application instance. Furthermore, what's necessary in Android is that we need to register this application here in this Android manifest XML. So that's really just a central manifest of settings where we declare such components like the application. So we just need to say Android name. And here the auto completion already tells us we want to link the meme creator application class. And then that'll work. For iOS, we actually need to do this in Swift. So Swift is the native language for iOS development. And iOS also has such an application class, but it's at a different place in this project. Not an iOS main. An iOS main would be the source set in which we put Kotlin code. That is, however, specific to iOS. But the entry point of the iOS application is here in this iOS app folder. So this is really the real native iOS code base in which we can find our real Swift code. So you can see we have two Swift files. On the one hand, a content view and an iOS app. And this iOS app is the entry point for our iOS application. In here, we can technically edit this here or in Xcode, whatever you prefer. We want to import Compose app first of all. Compose app is now the module that comes from the shared code. So all the code inside here, we can access this in Swift as well. That's another big advantage of KMP. And inside here, we want to have an init block. This is now Swift code. So this is just called in the moment the iOS app is created. So also just called once per iOS app application lifetime. And here we want to say init coin kt do init coin. So auto completion won't work here. But in the end, we can call Kotlin code here from Swift directly. And if we create such a top-level function in initCoin, then there will be an equivalent class generated on the Swift side that is called like the file name together with this kt extension. So initCoin kt, and then to execute such top-level functions, it will just be called do, followed by the function name. So do initCoin. That is where this comes from. But with this piece of code, that should hopefully work. So I would say now that we have coin set up, we should be able to pick a meme and navigate to our meme editor screen. So here, if we go inside and we perhaps also pass down this template that we've selected, since that is a navigation argument, it doesn't come from the view model. So this is one extra argument that we could pass here. The template would, in this case, need to be passed inside here as a meme template. We pass this down here, and then here we could also pass this template. Could be just a template for our preview. ID could be meme template 1, and the drawable would be res drawable meme template 1. But inside here, what we could do is, for now at least, we could simply have a box that fills the maximum size of our screen, and then we have a centered image that shows this meme template inside here. So maybe just say, okay, content alignment to center this, and then we have an image here, painter resource, and the resource is our template that we've passed here, that drawable. Content description can be null, modifier can be modifier fill max width, and the content scale can be content scale dot fill width. So it fills the maximum width of our images container. So far so good. We will change this, of course, just for testing purposes right now. Let's command click into this root composable to our navigation root, because here we now need to pass in this template. So how do we get that? In the end, we pass this to this route meme editor here, right? So we pass in the ID. But with this ID, we can derive the template together with a drawable that we want to display on the meme editor screen. And this works here inside this composable via it. So it is the nav backstack entry. So just an entry, a package that contains all kinds of information about the current screen instance. And we could get the template ID from that by saying it, so the backstack, to route. We want to convert this to a specific type of route, which is specifically our meme editor. And that will now give us an instance of meme editor of this data class. And if you want to reference the template ID, well, then we just type template ID. And then with that template ID, we can retrieve the real template from our list. Well, template is, for example, remember. So we just need to do this calculation once while passing in this template ID. And then we say, we take our meme templates, our static list, find the first element that satisfies our condition based on that ID being equal to the template ID we've passed. So we just take a look when we get to that screen at that meme templates list, and we find the template whose ID is equal to the ID we've passed to the route here. And then we found the template, which we can pass here to our composable. And I would say if we give this a go, launch this, for now just on Android, we can test iOS later. There we go, here's our gallery screen, nothing new at this point. But what we would expect is that if we now click on a meme template, we get to the meme editor screen, which shows that selected template in its center. So let's do that. Click here, and that's what happens. Right now, doesn't consider any theming here, of course, but we do see that specific template, which works now for all these different templates. Very, very nice. A little bit of progress again. As a next step, let's slowly get to the actual editor logic now. And that is actually a little bit tricky, especially here when it comes to adding those texts. So on the one hand, of course, what is a little bit tricky is being able to drag these around and freely transform these. But before we can actually implement the logic to drag a text around, we need to implement the text in the text field itself. And as you could already tell, this is not a typical text field. So it's in the end a very customized one that has a state where the text is simply displayed as a normal text, but also that we can click on that, select it normally in order to delete it. So there needs to be this state where we draw this border around it together with this close icon. And if we then double tap on it, then the same text suddenly turns into a text field where editing that comes with exactly the same look of this text. We can, of course, now make sure that it's always capitalized, which I think is the default for memes. That's something I didn't do here, but that is a fairly easy change. And something we also need to implement is this custom text style. Because on the one hand, of course, we need to draw it with our custom font, which is not the big deal here. But we want to draw it with a stroke and a fill. So we have a black stroke and a white fill color. And the normal text composable in Jetpack Compose, so we can also scale this up a little bit here so you can see this better like this. The normal text composable in Compose can either be drawn with a stroke or a fill color, but not both. And in the end, the way we will solve this here is by drawing two texts. So first of all, drawing the text that just has a black stroke, and then we draw another text with exactly the same properties, the same size, the same alignment, just with a white fill color in this case that is drawn on top of this stroke text. And then we bundle these together in a composable so that we can also drag these two texts around here at the same time. And this not only has to be done here for this text as it is right now, because this is really just a plain text composable, but the moment we actually double tap here, we swap that text composable out with a text field composable that lets us edit the text, because we only want to enter this edit state once we double tap the text. But let's do this one step at a time, and then it will all make sense by going to our meme editor here in presentation. And I typically like to put such custom composables, just single components of a screen, into a separate components package here inside the presentation layer. And in here, we can then create a new Kotlin class, or Kotlin file rather, which I want to call outlined. Let's call it outlined impact text. Impact is our font type. File, composable, outlined impact text. And then let's think about what kinds of parameters this needs. First of all, we of course want the text itself, so the text we want to render in this text composable. We want to have the stroke text style, so a text style property that gives us all the properties for the stroke text. As I mentioned, we want to overlay two texts here. And we want to have the fill text style, so that is just the counterpart to that, the text style that will come with a white solid fill color. I would also say we add a preview here in order to see what we're building. So outlined impact text preview. Here we will add our meme creator theme. And then in here we can have our outlined impact text. Give the text something like hello world, maybe capitalized hello world. And well, for these stroke and fill text, these are actually not just needed here in this outlined impact text composable, but also for the text field we are going to implement afterwards. So it does make sense to extract these text styles and creating these into a separate function so that we can reuse that logic. I would say we put this in perhaps presentation util, since this is not really a visual component that I would like to put in the components package. But let's create a little util package in here, and we have something like remember text. Let's make it in separate files. Remember stroke text style. This will be a composable function. Remember stroke text style. Doesn't need a modifier. It's not visual. And in here we can pass certain properties like the font size, which is a text unit, and we default this to 36 SP. Font family we can pass in, which we want to default to fonts.impact. The stroke color, let's pass that one in, is simply a color, and by default color.black. The fill color is something we want to, oh no, actually not for the stroke text style. Here we need the stroke width instead. Stroke width in form of a DP value. We default this to a 3dp. And I want to pass in the text align property, which we will default to text align at center. And in here, we can then simply return remember, where we pass in all of our properties here as keys so that we recalculate the remember block once any of those properties change. Stroke width, stroke color, and lastly the text align. And then here we can compute our text style that we can then easily reuse. The color of this text style will be our stroke color. Text align will be text align. Font size will be font size. Oops, not that one, font size. Then the draw style in Compose can either be fill or stroke. This must explicitly be stroke here in this case, because fill is otherwise the default. The width is, well, our stroke width, but here this stroke class works with pixel values, so with floats, we have that as DP values, so we need to convert that, and for that we can use the density, which we can get with local density.current. This includes information about the screen density, and depending on that, the conversion between DP and pixels is just different, but with this density, we can always do this fitting to the current device and density. We can do this via width density, and then inside here, inside this width block, we have the option to say, what is that? Stroke width dot 2 pixels, and that'll work. Then I want to set the stroke emitter to 10 pixels, and the stroke joins to stroke join dot round. That is the actual corners of the stroke. We just want to give them a little rounding here, and that is what we achieve with the stroke join. This, of course, needs to return something here, specifically a text style, like this. And then we want to have a similar function. I would even say we copy paste this into a separate file in here, which we call remember fill text style. And now we paste this here where we say remember fill text style. So this will be the counterpart to that. Simply the same text with the same font size, the same text align, just that this will be our white solid fill color. So let's pass in the font size, font family, Stroke color, no, but instead of stroke color and stroke width, let's use a fill color in form of a color, and that will default to white. Then we can replace those two here with fill color. We can replace the text color with fill color, and the stroke can be removed. So we default to a normal fill draw style, and therefore we can also remove the density since we don't need to convert between any DP or SP value. Okay, so now we have those two helper composables. That will help us with our outlined impact text here to render this text. So what we can now do is we can place those two texts that we now want to overlay in a box where we pass in our modifier. And the first text we now want to render is the stroke text. But this will now be super simple since we have those text styles already. The text should, of course, be simply our text. And then we set the style of this first text here to our stroke text style. And the same thing we now want to do for our fill text style. So we just have two identical texts, just with different styles. We overlay these here in a box in order to have this stroke and fill effect. We should also be able to test this here by going into our preview and passing in our remember stroke text style as well as our remember fill text style here. And if we then take a look in the preview, and we also need to probably rebuild our project, build and refresh, then there is our little font. For some reason, this doesn't look like the impact font, but more the default. I think it's a Roboto font. Not sure if this is the preview, but I mean, we do pass that as a default. Oh no, we don't pass the font family here, of course. Font family here and here as well. Right, so let's refresh our preview. And yep, that is looking much more meme-like now. And with that knowledge, we can now also come to the little bit more difficult part, which is creating the text field that will also render the same text, but let us also edit it in a more transparent fashion. So we don't want to have any visual text field. We just want to be able to edit this text here when double tapping on it. So here under components, let's also have an outlined impact text field. Make this a file. And here we can say composable outlined impact text field. And this will also need a few parameters here. On the one hand, of course, the text we want to render. We will get a callback when the text changes. So here we get a new text in form of a string. We want to pass in the modifier as a first optional argument. We then want to pass in the stroke text style, of course. We want to pass in the fill text style. And we want to pass in a max width DP value, nullable. And we can also set this to null initially. And we can also give these here default values, by the way. Remember stroke text style and remember fill text style, but also a max height DP value. Because in the end, I want to not make those texts that we render here scale infinitely, but rather define a maximum width and a maximum height past which the text won't scale and where it will start wrapping lines. So inside this composable, we will in the end make use of a basic text field composable. Basic text field is just the most plain text field that exists in Compose. By default, really just completely transparent and just brings us the text editing capabilities. So we could use this overload here, probably that uses a string. Think about if we need a string or text field value. Let's start off with a string. I think this will be fine by setting the value to our text and on value change. Here we can say we trigger our on text change lambda, but since we only want to support uppercase characters here for this text, we could simply uppercase whatever the input is. So here the new input dot uppercase. And then the view model later on will receive the uppercase variant and pass it down again to this text field. So that will automatically work that way. I furthermore want to give this a cursor brush. So the color of our cursor, a solid color of color white, color dot white. We want to set single line to false so that we support wrapping lines here. And now the tricky part again comes from actually overlaying these two texts, so the stroke text and the fill text, this time for text field. What we can do is we can pass a text style to this text field. So this will correspond to the text style of the text that is rendered in the text field. And this now, of course, needs to match exactly the look of this text here that we've already drawn when the text is not selected. That means here for the text style of the text field, we just want to render this with a fill text style. And then we just need to make sure that we render another text with a stroke around that. And with text fields, that works perfectly fine with a so-called decoration box. The decoration box is a lambda that looks super complex. You can see here two composable lambdas, but it's in the end a super simple principle. Let's first of all give this an inner text field name. Because what this decoration box parameter allows us to do is, we have a composable lambda, where we get another composable lambda, and this composable lambda here is really the content of the text field itself. So whatever text we've typed, and in the end, just the field where we can make certain changes to the text field. But now if you want to decorate the text field in some way, especially in a way that is dependent on the width and the text that has already been typed, then we can use this decoration box to say where and in which specific composable hierarchy this real text field's contents is actually placed. So we could, for example, say we render a normal text here, where the text is simply text, whatever the text is that is passed to the composable, and where the style is our stroke text style. And then if we afterwards call our inner text field lambda, that means we first render our stroke text style in the text field, and the real text field's content with a white fill color is then being rendered on top of the stroke text style, which again gives us the same effect we want by having those two overlay texts. Just that here in this case, the second overlay text is coming from the text field itself. And since we can't place the text composable ourselves here, like we were able to do here, also here we were able to construct our own fill text style and the text for that. But in the text field, the basic text field composable renders that somewhere internally. So we need to do this with a decoration box where we just say, hey, this would be the corresponding rendered text of the text field, and we want to render this on top of our stroke text style. So really just like here. Now, what is not yet considered is the actual max width and min width that we've passed in here. And we can consider this with a text measurer. So we can have a measurer equal to remember text measurer, and that is really just an object that has the responsibility to take in a text and then measure its bounds, so how much space that text in the end occupies. And then with that help, let's actually have a little helper function, which I will call calculate text constraints, which gets passed in our maximum width and our maximum height, and then returns a constraints object. So constraints object in Compose is really just an object that defines width and height bounds for an object in which it can freely move in. So if we construct a constraints object, well, then here we can pass in a minimum and a maximum width, and in between those values, which by default is 0 to infinity, our text will then be allowed to move in depending on how much space it wants and needs. And same thing for the height. And depending on those values here, we now want to calculate this constraints object. First of all, make this a composable because we need the density in here, local density current. And then we can say we return when the max width is existing and the max height is also existing. That means we can say with density, and we can construct a constraints object, which works with pixels. That is where we need to convert these dp values again, where the max width is simply our max width we've passed in here, and we round this to pixels, and same thing for the max height. So that way we say, okay, our text can really move in between 0 here, which is the default for the minimum values. We don't need to change those. So between 0 and whatever we've passed for those max values. If, however, we just pass a max width, but not a max height, well, then the constraints look slightly differently. So we can say density, take this constraints object, and just get rid of the max height. I think we can actually simplify this a little bit now when thinking about this. What if we just return a constraints object like this, but passed inside a width density block? If we do it like this, and we just make a null check here, and otherwise default to, what do we default to int, dot max value. Yeah, that works. Perfect. That is way simpler. So we just check if the max width or height exists. If so, we use the round to pixel value. Otherwise, we make it an infinity constraint, so we allow it to scale as much as it wants. Then we can take this function. We can calculate those constraints now here, where we pass in max width, max height. With that, we can then calculate a text layout result, which is now using this text measurer in order to really calculate the bounds of our text by saying text measurer, or measurer. Let's put this in remember as well, so we don't do this on every recomposition. But here we can say measurer, measure. The text we want to measure is simply our text, which we would also need to pass in as a key here, as well as our stroke text style and our constraints. The style for the text we want to measure is our stroke text style, and our constraints we want to measure with are our constraints. And then with that text layout result, we can derive our actual final text size, or let's call it text bounding size, because this is the size of the bounding box around the text, so we don't confuse it with the font size. This is also equal to width density, local density current. Don't think we need this else right here. Where we say that is a dp size, where the width is equal to text layout result size dot width dot 2dp, and the height is text layout result size dot height 2dp. And now this is the size that we can pass in as a fixed size or preferred size for this basic text field simply via a modifier. So we go in here, say modifier size, and we pass in this text bounding size. And this way we give it a size where we really consider that max width and max height constraint, where we also make sure that if we scale up the text and it exceeds our max width or max height, that it automatically wraps lines, because we gave this basic text field here a size it won't scale beyond. So now we have this text here that we render if the text is not selected or is just in the normal selection state where there is just the close button. And we have this text field which renders the moment we double tap on a text and want to really edit it. The next thing we need is another composable that bundles and in the end combines those two text composables we've created and just shows the right composable conditionally depending on our current state. So let's go in here and create something like a meme text. File, composable, meme text. Let's maybe call this meme text box. Yep, rename all that. Then in here, we want to pass in our meme text, which we already have a class for. We want to pass in an isSelected boolean, which would be true if we click on that. Then we want to show this white border around it. We want to have an isEditing boolean, which would be true if the text is really being edited. I think we can actually pass in the text box state that we already have, because that comes with both these variants, and also make sure that these are mutually exclusive, so only one of these can be true at a time, which isn't the case when passing in two individual booleans. Let's have an onClick lambda that we pass here when we click once on the text box in order to enter the selected state, but also an onDoubleClick modifier in order to enter the editing state. We're going to have an onTextChange lambda that gives us the new text once it has changed. We want to have an onDeleteClick lambda, which triggers when we click on the close or the delete icon for the text so we can remove it. And let's also pass down our max width here, as well as the max height for our text, if we want that. Okay, first of all, I want to have a box here with our root modifier that we place our composables in. This box will in the end help us to align this close icon here just to the top right corner of this box. Inside this box, however, we will place another box which will contain our outline text or the outline impact text. So let's have another box here where we say the modifier is equal to a new modifier. We say size in, and we pass in our max width and our max height. We give it a border, so we have this white rendered border here, which will get a width of 2dp. It will get a color of, depending on our selection state. So if our text box interaction state is text box interaction state selected, or text box interaction state is text box interaction state editing. In both these cases, we want to show the white border around it. So in that case, the border color can be white, color dot white, and otherwise we set it to transparent so we don't see the border. Also, let's give it a shape of a rounded corner shape of, no, let's say 4dp. Furthermore, I'm not sure if you can see this well here, but if we unfocus this, you can see there is a very slight black background here when we're in the editing state, so that we give it sufficient contrast. I would also like to add this here via a normal background modifier. We can give this a color of, if we're editing, if the text box state is editing, then this should get color black, but with an alpha value of, I don't know, 0.15f, so 15% transparency, and otherwise just no background. Shape can be the same here as our actual border, rounded corner shape for dp. And lastly, we want to have not a clickable, but a combined clickable. A combined clickable in the end comes with some extensions, how we can extend a normal clickable modifier, for example, with a double click. So here, combined clickable, where we say on click is simply on click, and on double click is on double click. Okay, so now we have this box that really surrounds our normal text and the text field. So in the body of this box, what we can do is we first of all want to get our stroke text style instance from remember stroke text style, and we want to get our fill text style, remember fill text style. We also want to define some text padding here. which I'll set to 8 dp. So this will be the padding here between the white bounding box and the text. You can see it's not exactly at the edges here, but there is some padding. So it means if our text box interaction state is now in the editing state, so we are actually here in this state that I'm currently in here on the left, that means we want to render our outlined impact text field composable. Outlined impact text field. Here, the text will simply be the text, the meme text dot text. On text change will be on text change. The stroke text style will be our stroke text style. Fill text style, fill text style. The max width will be our max width. However, we need to also account for the padding that we will add here to this text field. So we say minus text padding multiplied by 2, because the actual maximum width of the text is of course a little bit less than the maximum width of our surrounding box. Exactly twice the padding, so once on the right and once on the left side. Same thing for the height, so max height minus text padding multiplied by 2. And then we of course also need to give it this text padding by setting a modifier of padding with text padding. If our text box interaction state is, however, not editing, so in the else case, then we want to render our outlined impact text, so without any editing capabilities. Here. So here we want to render our outlined impact text, where the text is meme text text, with the same styles, stroke text style, fill text style is fill text style, and same padding, so modifier padding with text padding. So that there's no real offset here when switching between these states. So we need to make sure that they take exactly the same space. Okay, that should be it for the text itself. We still need to render this button here, the close one. That does not go inside of this box, but inside of this surrounding box. So inside here, just here. But we only want to render that if we are in the selected or editing state. So again, same if statement like here for the color. Then we can actually draw this icon button. Maybe a little tip here. You may be wondering why I don't make this check here negative, or negated, I mean. We could simply check if the text box interaction state is not none, because if it's not none and there are only 2 other options, well, now that means it must be one of these. But that is a little bit brittle because, where was I at? Meme editor, meme text. Now I've lost my, here, meme text box. Because imagine at some point you add a 4th text box interaction state in which you also don't want to render this close button, then by default your code will break. And you would have to remember actually to fix this if statement, and not only this one, but possibly multiple ones in your code. So it's a bit more explicit to say in which states we definitely want to show that, rather than saying in which you don't want to show it. Okay, in here the icon button is actually not really an icon button, but a normal box that acts like an icon button. Give it a modifier of give it a size of 24 dp. Say the alignment inside the box is alignment.top end, so top right corner here. We say we offset this a little bit. You can see it's the top right corner. Normally it would be here, but we want to move it a bit to the right and a bit to the top by exactly half its dimensions, so half of 24 dp. That means the x offset should be 12 dp. So 12 dp, moving it to the right, and y should be minus 12 dp. So we move it 12 dp to the top. We can then say we clip this to a circle shape. We can say we give it a background color of, I'll just use a hard-coded color here, which is 0xFFB3261E, so just a red color. It's only needed here, so let's not overcomplicate this. And if we then click this, here we can use a normal clickable modifier, then we want to trigger our onClick lambda. No, actually on delete click. And the child of this box is then a normal icon. Also make sure that it's centered here with content alignment.center. And the icon here, the image vector specifically, can be icons. Didn't we add the icons dependency? Let me take a look. In project, build a Gradle. Here, let's duplicate one of these. Is there a material here? Material icons extended. Let's add this dependency and sync this. Okay, that sync was successful. So let's close this again. And now we can import icons here without enter. Icons default close will be the icon, so simply a close icon. Let's also open this again. Content description here. Let's set this to null. Tint of this icon can be color.white. and the modifier of it will be 16 dp in size, so size 16 dp. Okay, so that is it for the icon, which we conditionally show depending on the state. We're not yet fully done with this composable, because we also need to implement a little bit of focus management here, so that if we double tap this text, that we also focus the text field and put the cursor at the right position. That works via a so-called focus requester. Let's call it meme text focus requester is equal to, remember, focus requester. Here, focus requester. And we want the focus manager, which can allow us to just control focus, like the more general focus, for example, to just clear the focus wherever it is. We can get this with a local focus manager. It's current. And I want to get the keyboard controller in order to show or hide the keyboard. And that we get with a local software keyboard controller .current. Then we can say launched effect. We pass in the text box interaction state. So this block now triggers whenever the state here changes. Because if that text box interaction state has changed to editing, then that means we want to take our meme text focus requester and simply request the focus. So if we jump into the editing state for a particular text field, then we automatically want to open our text field and focus it. I will add a little bit of artificial delay here to just make the keyboard appear a little bit more fluently. So afterwards we can say keyboard controller .show, and this will simply show our keyboard after having focused our text field. Same thing we want to do, so let's just copy this. On the one hand for the text box interaction state, but also when the, meme text.id, when that changes, here we are not in the selected state. So if we unselected a particular text field, or it's a completely different text for some reason, then we can say focus manager clear focus. So this will simply clear the focus and also probably hide the text field in that case. But we also have a mechanism later on that if we simply tap outside, this will also achieve the same result. Now, in order to also make sure we can request a focus here, we need to link this focus requester to the text field. So we simply need to add it here as a modifier. Focus requester is our meme text focus requester. And I think that is it for this meme text box composable. And I would suggest we test this by just hard coding such a text box here in meme editor, where we currently just show this image. But for example, on top of this image, we could now render our meme text box. Meme text box. Maybe, well, let's actually already implement the view model action so we can really change and mutate our state. So here, first of all, we have the meme text, which I think this is one that we need to, oh, well, whatever. Let's just hardcode things for now and see if we can at least focus the text, and then we'll work on really mutating that next. ID can be something just for demonstration purposes here. Text can initially be tapped to edit. Font size can stay the default, and all the rest can stay the default as well. Text box interaction state is state text box interaction state. So that is something we should be able to fairly easily implement in the view model in order to pass in the max width and height. Let's for now just hardcode this. 500 dp, which should be sufficient to render this text. On click, here we can already trigger an action, meme editor action on, on select meme text. And here we pass in the ID of the meme text we clicked on. We have an on double click where we say meme editor action on double or on edit meme text also with our ID. We have the on text change where we can say on action meme editor action on meme text change with the new text, and probably also, this is the ID for which we changed that, and the new text is it. And on delete click is on action meme editor action on delete meme text click, and we want to delete the text with hello. Let's see if we can implement some of these actions fairly quickly in our view model. So here we now receive those when we trigger these from the UI. So for example, when we say on edit meme text, and we can say edit meme text, pass in the ID of the text we want to edit, or we want to put in the editing state, Alt Enter, create this function. This I think is an easy one. Don't return anything here. And we say state update, and we set the text box interaction state to text box interaction state dot editing now, and the ID that is being edited is whatever we've clicked on. Similar to that, we should be able to go in here on meme text change, change or update meme text. We pass in the ID and the new text. Alt-Enter, create this function. I'm not sure why it always wants us to return nothing. The text is not text2, but just text. Here we can say state update. And here we in the end want to take our meme text, which is a list, iterate over that, find the right text with that ID and update the text to this one here. So we could say we take the current meme text, we map those, and we check if it, so the current meme text ID, is equal to our ID. And if so, we just replace it with the current meme text, copy, and set the text to our new text. And otherwise, we leave the meme text unchanged. We can also give this a text here, a name, meme text. So it's a bit more explicit which text we are mutating here. Meme text ID is ID. Meme text, here. This one needs to be meme text. Then we need the selected state on select meme text, select meme text, pass in the ID. And here I think we only want to update our state accordingly. So state update to the text box interaction state. Text box interaction state selected while passing in this new ID. No, ID, not it. And yeah, when we're already on it, let's just finalize this and implement it as it should be with everything, because now we're already so far, and then we can hopefully test the editing logic fully already. What is missing? Deleting a text, right? On delete meme text, click, delete meme text, pass in the ID of the text we are about to delete, Alt-Enter, create this function. Here we want to say we take the state again, and we now need to find the meme text with the ID in our meme text, and in the end, filter it out. So we say, take our existing meme texts and we filter them based on their ID. We can also, again, give this a name, based on the ID of the current meme text not being equal to the ID that we want to remove. So we keep all texts where this condition is true, so where the ID is not the one we want to delete. And that, I think, is what we need. So we can't yet add text, but what I would say is, instead of, where is that here, meme editor, instead of creating the text here, we just create this as a default text in our meme editor state. So here, not an empty list for testing purposes, but we create a normal list with one initial entry. And then in the meme editor, we want to take this list of meme text and iterate over that to get each meme text. And for each one, we show a meme text box. We pass in the meme text like this. And we need to swap out these hellos here with the corresponding ID, where we say meme text dot ID. And in case you're curious how I got these multiple cursors, that is Shift and I think it's Alt for me. I swapped my keys, but Shift and some kind of other Option key, Option or Alt it is, holding these down, and then you can select multiple parts here of your code and then edit these at the same time. Pretty cool. Okay, I would say we try this out. Let's run this on our Android device and take a look. I'm not sure if we're missing something. I wouldn't be surprised if we are, but let's give it a shot. There we are. Here are our templates. Let's select one. And we get to the screen here where we have our text. You can see if we hover over it, we have this little outline that we can click on it. If we click on it once, we select it. We, of course, can't yet move it around. That logic is not yet implemented. But if we now double tap, then, yep, we can edit it. Perfect. If we now type something, hello, then this looks pretty cool. We can't yet tap outside to unfocus it. That is also something we would need to implement manually. We can hide the text field. I'm not sure if we can remove the focus somewhere else. No, doesn't seem so. Very cool. So we can edit our meme text. If we click on the close icon, well, then we remove it. Awesome. That is a very nice foundation to now work on the next part. On the one hand, of course, unfocusing the text field when we tap somewhere else. Also giving the screen a little bit nicer layout to stick to our theme. But mainly to also be able to now drag these around here in the bounding box of our image. Okay, let's give this code a bit more structure so that we can slowly get to such a draggable container. And that's actually the next thing that I would like to build. A separate composable that just makes up the image part and serves as a draggable container. So just a container in which we can freely drag around our texts. I would say we put this in meme editor presentation components, draggable container, make that a composable that is called draggable container. And, well, it is going to need a modifier, but also some more things. Specifically, a list of children. So all those children we want to place in the draggable container. So in our case, our meme text. It furthermore needs to know the text box interaction state. It then needs to know a lambda on child transform change. So the moment we somehow move, rotate, scale a certain child, a certain meme text in this container, we of course need to bubble this information up to our viewModel later on in order to also persist this change, at least in our viewModel. So when that changed, we pass an offset from material 3, Compose UI geometry, this one here. So that is just the translation of the item, so where it is positioned. We want to pass a float for the rotation. Let's give it a name, since we will also have a float for the scale. And whenever any of that changes, then we bubble this up. Let's also give this one a name, just to be consistent here. And we of course also need the child ID in form of a string. So we need to know which child the transform was changed for. And what else do we need? Well, we just need all those other lambdas that we can get from such a meme text box. So on click, double click, text change, on delete click. Let's go in here and we say on child click, pass in the child ID that we clicked on child double click, same thing here, on child text change. Here we do need 2 strings, right? So the ID and the text. So let's also give these names again so we know which string corresponds to what. First of all, the ID and the text. And what else? On child delete click. And here we also want the child ID. I think that is it in regards to parameters. Inside this draggable container, we need to know the dimensions of this container. Because the dimensions, so the container will in the end span, will span the dimensions of our image, and the image will also be placed inside this container. And we need to know the image dimensions in order to also know in which bounding box the text is allowed to move in. And if we want to know such a container width and height, we can use a box with constraints. This is kind of a special variant of a normal box composable that gives us this constraints object, so exactly the constraint minimum and maximum width and minimum and maximum height for particular box here. So inside here, we could then get the parent width by saying constraints max width and the parent height by saying constraints max height. And then we can work with those values here inside this scope. What we want to do inside this box with constraints is we want to use our children and iterate over these. So we get a bunch of meme text from our viewModel state. And for each of those, let's call it child, we want to render such a meme text. What we now need to know for each child is the dimensions as well. So on the one hand, we have dimensions for our parents, so the actual container in which we place those children. But of course, every single child, every single text also has a bounding box that we need in order to calculate certain transform values. So we will have a child width, where we say by remember, and this is something we can really place inside here, inside this for loop. It's very important that we pass in the child ID here. I will say something about that in a moment. But we can make this a mutable state of 0 initially, Alt-Enter to import that, and then we'll have the same for the child height. And that will also start at 0. Now the reason we need to pass in this child ID here as a key, so that whenever that changes, we will recompute that state, even though that key is not necessarily used inside the state here. In order to understand why we need this, in order to avoid bugs, we need to understand how remember actually works. Because remember in the end has the job to remember a certain value across recompositions. So we don't want to recalculate the state and set it back to 0 when there is some kind of recomposition. And you might now wonder, okay, we could still do it like this, and then we would still have this remember call for this particular child, but without passing in a specific key. The remembered value is remembered based on the position of the composable in this for each loop. So it will use the actual kind of index of this child in this list in order to then later know which particular call to remember corresponds to which particular item in this for each loop. However, if we now make changes in this children list, so for example, we delete one of those children, and there were 2 texts that were shown initially, we then delete the first one, then the new list size will be 1, so there will be 1 remaining text. And what Compose will do now is it will reuse the cached value, so the remembered value for item position 1, but for item 2. So our items will make a jump in position in transforms because it will think, okay, there is still an item for position 1, but it's unable to detect if that is the same item instance. So if that is the same meme text. But if we now give this a child ID, then it will only recompute that if the ID, the identifier of this child, actually really changes. So it doesn't use this index anymore of this list, but rather the child ID. And therefore it knows, okay, this child ID is still there. That means it must get this remembered value. That other child ID was deleted, so we can also delete the cached value here from remember. Okay, but let's actually move on here, because we now also need to store, actually these need to be vars, because we of course need to change those values. And then we need to import this extra set value delegate. But we also need a few more states, specifically the scale. So scale by remember, same thing here, child.id. And the scale, so the scale of this particular child will initially be a mutable float state of, and initially be 1f. Here we actually want to use remember savable, not just remember, because remember does not survive configuration changes in Android, so things like a screen rotation, changing the device locale. And this is a value that we would also want to persist across configuration changes. So if we scaled up a certain text and we rotate the device, then we expect this text to still have the same scale. And that is why we want to use remember savable. The alternative would be to put this and save these values for every single child individually in the view model. Or actually, when thinking about, we do save those values already, right, in our meme text. Yeah, here we have the scale, rotation, and offset already that is part of each individual meme text. So I don't think we need to keep these separate in our draggable container as a state, because we already get that from the view model. So let's remove that. We should not need that. But let's move on, because for every single child, we now want to display a box in which we render this meme text. Give this a modifier of modifier on size changed. So when the size of this box changes, that will be the size of this particular child. Then we can update our local states here. Child width is equal to it.width, and child height is equal to it.height. Then we can say we apply a graphics layer modifier. That's in the end a modifier that lets us mutate the transform of this particular box composable. And that's exactly what we want, because here we can set things like the translation x. So how and by how far this composable is moved on the x-axis. And that is exactly the child offset ratio x value that we have. Remember, this is still just the ratio, a value between 0 and 1f, while this translation here wants an absolute value, so a real amount of pixels we want to move this. So what we need to do is we simply need to multiply that ratio with our parent width, so the entire available width that we have. Same thing with our translation y. Here we can say child offset ratio y multiplied by parent height here. And again, a little recap, the reason why we save this as a ratio here is simply because if we rotate our device, then the dimensions, or the, not the aspect ratio, but the absolute width and height values of our image can change. And we still want to make sure that our child gets placed at the same position after having rotated it. If we save these as absolute values, then these absolute values, or the absolute offset, won't be the same anymore after a screen rotation if the dimensions of the image have changed. What we also want to do is we want to set the rotation z value. So the z-axis is the one that goes inside the screen, and that is what we want to rotate around. We want to set this to child rotation, and we want to set the scale y and x to child.scale, like this. In general, it's super important that you, if you need to do these transformations, that you rely on graphics layer, because we can, in the end, do this without relying on any unnecessary recompositions from Compose. Because you'll notice there is also a scale modifier here. There is a rotation modifier, or rotate. There is an offset modifier. And these all will work the same. But the moment you actually read a value state in Compose inside the composition, so in a composable context, then that can cause a recomposition when that red value changes. However, here we are not inside of a composition anymore, even though it may look like that. This block of code here, so the graphics layer lambda, is not a composable function. And it's particularly executed in a different phase. So in Compose, handling a single frame always consists of 3 different phases. On the one hand, composition, where it's decided about how each element is, or how the entire UI tree is laid out. Then we have the layout phase, where it's decided how large and where a specific composable, or all specific composables, will be positioned. And then we have the drawing phase, which is all about deciding how these components look like, so which background color, but also things like the individual transform. And by placing this inside this graphics layer scope, Compose only needs to re-invoke the drawing phase, but not the composition phase and the layout phase again, because it knows if something changes in here, well, then these other phases remain untouched. But these are really more internal details and more advanced knowledge that I go into in a lot of detail in my Jetpack Compose Masterclass, which is also just as applicable to Compose Multiplatform as it is for native Android, since the mechanisms under the hood of both these frameworks is the same because it's the same framework. So I'll also include a link to the Jetpack Compose Masterclass in this video's description in case you're curious about that. Okay, but inside this box, so here, we in the end now want to render our meme box, the meme text box. Let's take this one, this composable, and cut it out here from the meme editor screen. Move this into here. The meme text here is simply our child. The text box interaction state, that is passed to our draggable container. And here we need to just slightly fix these lambdas. So we can just say on child click. That doesn't work. Okay, on child click, we invoke that. All right, because we need to pass the child's ID. On child double click, child ID. We have on child text change, child ID, and the new text, so it. And lastly, on delete, on child delete click, or child ID as well. For the max and max width and max height, we don't want to hardcode this to 500 dp anymore, but we want to set this to whatever our parent width and parent height is, because those are the constraints in which we want the text to move in, and which we want to tell the text box about to wrap lines in case it's necessary, in case the text would exceed these constraints or these dimensions of the parent container. So instead of setting this to 500 dp, what I want to do is I want to define a density again, since we need to convert our constraints pixel values here to dp values. And then we can say with that density object, we say, okay, parent width 2dp. And here we say with density parent height dot 2dp. So now you would think it's almost it, and it is almost it. But a very important part is, of course, missing. This code here is enough to really show each child at the right position by giving it the right transform values, not only the right position, but also the right rotation and the right scale. But right now, this code, of course, does not support really pinch to zoom, actually dragging these around, rotating these with our fingers. So how does that work? And for that, Compose actually has a pretty cool modifier that I don't want to say it makes it easy. It seems like it's easy because what we need to do in the end is we need to say we have a transformable state, which we get with remember transformable state. And this in the end gives us a lambda here with 3 values. On the one hand, this is the scale change. This is the pan change or the offset change. Well, let's call it pan change. And that is the rotation change. So this state, when passing this here to a modifier via transformable, will intercept these gestures. So it will listen to rotation gestures, it will listen to scale gestures, to moving around gestures, and give us the new value. So by how much the scale has changed due to the gesture, by how much the pan has changed, so how much we've moved this text in this case, and by how much we've rotated it based on the touch gesture. And all that seems super simple, but you'll notice very quickly that this is not sufficient. And we actually need quite some math here in order to make this work. Because we could, of course, now go ahead and say, well, new rotation is simply the current child's rotation, and we add however many degrees have changed on top of that existing rotation. We could additionally say new scale is equal to the current scale of the child multiplied by however much the scale has changed. And then we could also say something like chorus in, where we say, okay, the scale must be between 50% and 200%, so that we can't infinitely scale this item. And then you may think, okay, we just create a new offset, which is just an offset value with an x and a y position, where the x position is the current offset ratio x here from the child, multiplied by the parent width to get this in absolute numbers. And we simply add the pan change dot x on top. So however many pixels this has moved in x direction based on our gesture. And the same thing for the y coordinate. So we could just copy paste that. Here we have the offset ratio y, parent height, and pan change y. And then with those new values, we could say, okay, on child transform changed, passing in the ID, which is child ID. The offset is the new offset, rotation is the new rotation, and the scale is the new scale. ID here, of course. So we bubble those values up, and no worries, we will need this code here, but we will need more code in order to make this work. So I'm not just writing this to show you that it doesn't work. This is part of our journey, but I still want to show you why it doesn't work. By going to our meme editor screen now, And here we have our for each loop, which we don't need, but we do need our draggable container composable now that gets rendered on top of our image. The children will be our state meme texts, the text box interaction state, text box interaction state. On child transform changed, here we're going to call on action, meme editor action, on transform something, on meme text transform change. The ID is, here we get all those values, right? So ID, what is that? I think offset rotation. For some reason it doesn't show the names here, but it is offset rotation scale. Okay, offset rotation scale, ID, offset rotation and scale. And then the next argument would be on child click. Here we say again on action, meme editor action, on meme text click, on select meme text we called it with the new ID, on child double click, on action, meme editor action, on edit meme text, on child text change, you get the ID and the text, on action, meme editor action, on meme text change with the ID and text, and lastly on child delete click, on action, meme editor action, on delete meme text click, and we pass it. And furthermore, what I want to do is I want to say modifier is equal to modifier match parent size. So we give it exactly the same size as this image, or actually as this box here, which is actually not what we want. We want the draggable container to be as large as the image and not as the whole screen size. So let's put this inside another box, which we don't give a fill max size modifier. So by default, it will just expand as much as the children need. And in this case, since we only have those two children, it will be as much as this image. Then here for this image, whenever that size changes, we want to notify our view model about the size. So we say on action, meme editor action, on container size change, where we pass in the new int size, which is actually just it, right? Could just pass it, yeah. So just the new size here of our image. And then this whole box here, that one I would like to place in the scaffold, because the scaffold I would then like to give a bottom bar where we can place our two buttons in order to edit text in order to later save the meme. So scaffold, we give it a modifier fill max size. We move this box in here. What I also want to do is I want to give this pointer input modifier as a unit here, and we want to detect tap gestures. This is in the end just a callback that gets invoked the moment we tap somewhere on the screen without giving us any ripple effect or so, because in this case we want to send an action, meme editor action, on tap outside selected text, because if we tap somewhere on the scaffold, then that means we want to unfocus the text, so we send this to the view model and we can clear the focus that way. Here we also get our inner padding that considers the window insets when being used, which we can use for this box here. So padding, inner padding, and then the last thing that I want to do in order to test this now is I want to go to the scaffold and add a bottom bar. This is super simple, really just a simple component that lets us show our two buttons. Bottom, actually, yeah, we need to probably create our own little bottom bar that is just a row with two buttons. So in components here, we create a bottom bar, make this a file, bottom bar, we get a callback on add text click and on save click. So to respond to clicking on these two buttons, maybe to give you some context here, this is the finalized app. We just want to have those two buttons here in the bottom bar. So really just a row, we give this modifier. We can set the horizontal arrangement to arrangement spaced by maybe 60 dp to have 16 dp of spacing between these buttons. Maybe we also give it some padding of say 16 dp. And in here we can then place our buttons. On the one hand, a material button on click will be on add text click. Inside we have a text add text, and this is actually an outline button, not a normal one. So let's make this an outlined. We then have a normal button after that, so a filled one, on save click with the text save meme. And I would also set the horizontal arrangement to end so that these are right aligned, which would be better in regard to UX because they are closer to the user's thumb. So we can simply set this to alignment dot end, and then we can combine this together with the spacing. Nice. This bottom bar we can now place in this meme editor here in the scaffold. Bottom bar on add text click. Here we can trigger our on action, meme editor action, on add text click, on save click. Here we will also trigger an action, meme editor action on save meme click. And the meme template is just the template that we have here and that we're currently showing. Other than that, not sure if we need to necessarily fill the full width. I would say we put this in here because every bottom bar fills the maximum width, and then we have that enforced and implemented by design for this bottom bar. Okay, the last thing before we should be able to test dragging, rotating, and scaling our text, at least in some sense, is we need to go to our view model and respond to, actually just this action, and perhaps this one, since we need to be able to add some text in order to be able to transform these and drag these around. And we need to respond to the transform thing here, the transform action. So let's go to meme editor view model, on add text click, add text, and here we get, no, that's actually, doesn't need parameters. Alt enter, create this function, returns void or unit. Then we need to decide on a few values. On the one hand, we need to generate an ID. The ID via a UUID, I would suggest that's always the easiest to generate a random string ID. So UUID random toString. Alt enter to opt into this experimental API here to this whole file. So we get rid of the warnings. We then need to agree on a position of which I would say we choose based on the dimensions of this box of our image, which we know in the view model. Do we already update that? I think so. Container size here, update container size. Whenever that changes, we update our template size and the state with a new size. This new size is also already passed there, here in the meme editor, exactly here. When the image's size changes, we send this to the view model. So we know this in the view model, which means we can go up here to add text, get the template size from our state value template size, and then we can have the position be equal to if the current, if the template size is not int size.0, so this has been initialized already, which should pretty much always be the case here, then we can set this to an offset, where I would say, okay, we use the template size, that width, and maybe 25% of that. So we place remove this one here, and we place, just like here, place the top left corner. This is always where offsets are measured from by default in a canvas. And we place this 25% in from the width of the parent and 25% from the height, which I think is a decent place to put this. Here, y will be template size.height multiplied by 0.25f. And well, otherwise, if for some reason this is not initialized, we can just set this to an offset, maybe 100 pixels by 100 pixels. Then we can construct a new meme text box. So meme text is equal to meme text. The ID is our ID. The text can be to edit. The font size can remain that, but I would actually like to change this to SP. I don't like to work with pixel font sizes, which a float would be by default. But let's change this to SP and make this a text unit instead. So the font size can still stay 36 SP. The offset ratio X, well, we now need to take this absolute position. So this will be absolute pixel coordinates here. Oh, well, actually, when I think about it, we don't need to calculate this. Originally, I've implemented it that way that I only work with absolute values just to then later fix it to not have this rotation issue. I think it's even easier. I think we can really just say 25% here for the initial offset, because that's exactly how this works. And then we can say we get rid of that. Much easier. The rotation can stay 0 by default, and the scale can also stay 1 by default. Don't think we need the template size here now. And then in here, we can say, finally, we update the state and add this new text to our list. So meme texts is equal to the current meme text plus the new meme text. We also want to immediately move this new text in focus so that we can edit it, or at least select it. So we set the text box interaction state to text box interaction state selected, and the text box ID that is selected is now the ID of that new meme text. Okay, that's our add text function. Let's maybe also implement this one quickly when we tab outside. What do we do? Unselect meme text. So here, Alt Enter, create this function. This is super simple. We just want to reset the text box interaction state to none. So text box interaction state at none, so that no box is selected when we tab outside here. Is there anything else? Here, meme transform change. That is, of course, important. Transform meme text. And here, well, we need to pass in the ID. Let's give it named parameters. We have the offset, we have the rotation, and we have the scale. And then again, Alt Enter here to create this function with those values, offset, rotation, scale, doesn't return anything. And well, here we just need to iterate over our list of meme texts to find the one that we want to, meme text, to find the one that we want to change the transform for. So we get each meme text here in each iteration. And then we want to say, if that meme text we're currently iterating over has the ID that we've passed here that has changed, then we want to transform this meme text here, specifically changing the offset ratio X. We also, by the way, need the template size here. So let's reformat this slightly by saying template size is equal to it, so the current snapshot of this meme editor state, dot template size. And we could even extract the width and the height out of that. Width and height. Offset ratio X will be the new offset that we pass to this function. Dot X multiplied with our width. Offset Y multiplied by height. The rotation will be the new rotation and the scale will be the new scale. Something like this. And if this is not the meme text we want to change, well, then we just leave it unchanged. Okay, I would say that is how we change our local state. Is there perhaps anything we need to adjust here? No, the other actions we didn't yet implement. So I would say we give this a go. Let's quickly take a look here, but I think we have everything. As I mentioned, this won't work yet. It will work in some way, but not yet in the way we envision. There we go. The app is launched. Let's open our meme. Okay, our initial text is still there. Let's delete that. But if we now click on add text, then there's our new text. And if we take this and, okay, we drag it, then it's gone. That is not what I expected. We click it, but we drag it and then it's gone. Perhaps that is related to how I change the offset here. It could be that this pan change... Okay, actually, no, I found the issue why this was jumping somewhere very far away. Here in transform meme text in our meme editor view model, of course, need to divide by the width and the height because we are getting the absolute offset from the UI. And we want to transform that absolute offset into a ratio, into a value between 0 and 1. And therefore, we, of course, need to divide by the dimensions. That is one thing. The other thing is that is a tricky one, our box with constraints needs to get this modifier being passed in. Because otherwise, by default in Compose, composables have a maximum height and width constraint of infinity. Because in theory, they could be infinitely large. But only if we pass in a modifier. And this modifier changes the constraints in some way. That's also something I go in a lot of depth in the Compose Masterclass. But if a modifier changes the constraints in some way and shrinks the maximum constraint, only then we get the accurate values. And that is the case here, since we pass down the match parent size modifier, which will adjust the constraints. So the maximum constraint will just be as much as our box is. Okay, let's relaunch this with these changes. And in here, we click on our meme, click add text. Let's now drag this around. And you can see that already works. We can add another text. For some reason, they're both selected. That should not be the case. So if something is selected, okay, that's something we need to take a look into. But we can drag these around. Let's first of all take a look at what happens if we try to rotate one of these texts. So we can rotate this and scale this. So it seems like it's all working. But if you leave it rotated and then try to move, maybe with my mouse, that makes it a bit clearer. I take my mouse and move to the right. And then you can see this goes in a completely different direction than where I'm actually dragging. If I drag to the top side, then it goes diagonal. And also what you'll notice is, if we scale this very large, then it's very slow. So the more we scale, the slower our drag is. And the more I have to move my mouse or finger in order to move the same distance. So let's take a look at that. And let's also take a look at this selection state. Since when we select a meme text here, then we get the ID. Here in the V model, we need to take a look. Select meme text. We change this to the new ID. I think I know where the issue is. In our meme editor, I remember we checked for whether the selection state is just selected, but we don't additionally check the ID. Is this here? I think it's in our meme text composable, meme text box. Here, we also need to go down where we decide about the color. Let's make this in a separate variable, perhaps. Is this or is meme text selected? And That means this needs to be true. That is correct. But additionally, let's put this in parentheses. Additionally, you want to know that the textbox interaction state, textbox ID, is also our meme text ID. So is also the ID of the current text we're drawing here. Same thing for the editing state. Textbox ID is equal to meme text ID. And then we can use this here for our if statement. If that is selected here, this one we only want to draw when we are editing, not when we're selected. But then let's just do this manually here. Textbox ID is equal to meme text.id. And down here, we also need to check this. And textbox interaction state, textbox ID is meme text.id. And down here, we can reuse this. Is meme text selected? This should better do it, I think. Let's try this again. So the scaling issues will still persist, but we should hopefully be able to add a text. And now we can move that around. We can tap outside to unfocus it and focus it again. Add another text. And yeah, now you can see that one is selected. We can unfocus that. We can focus that one, focus that one. That now works. And we can also remove those texts again. Very nice. So far, so good. Let's fix those transform issues next. And as I mentioned, this will be a little bit math heavy. And we first of all need to understand why this even happens in the first place when going to our draggable container. Here. The thing is, in JetBrains Compose, modifiers are being applied sequentially. That means, first of all, this modifier is applied. Then the graphics layer modifier is applied, which makes these changes. And then the transformable modifier is applied, which in the end intercepts the gestures, the pinch to zoom, and dragging around, and then gives us these new values inside this transformable state. Now the thing is, since modifiers in Compose work sequentially, and this graphics layer modifier is applied first, all these values and transforms will rotate and will scale the underlying canvas's coordinate system of this box. So the moment we rotate our text here, then the coordinate system will be rotated with it. So the x-axis for this text here is technically here, and the y-axis is here for all subsequent modifiers. And that includes our transformable modifier. So that means if we now drag on the normal x-axis here, we actually make the composable move in a completely different direction. So this means we would actually need to drag the text to its local right side in order to drag it to the real right side of the coordinate system, as you can see. And also, since the scale here scales up the coordinate system, and therefore just really bloats it up, that means on that scaled coordinate system, we need to move past much more pixels in order to cover the same distance. And that is why we need to drag more in order to really move the same amount of this text here. Unfortunately, we can't simply swap these modifiers. So if we put the transformable modifier before and then we apply the graphics layer, then this doesn't work because the gestures will be listened to before increasing the scale and the rotation of our box here. And therefore, the actual touch area in which the gestures would be recognized is not accurate anymore, since these transformations are being done after intercepting these gestures. So if we now relaunch this and try this again, add a text here, nothing really works. If we, you can see somewhere we can actually move this, but it's not really the intuitive way anymore, because all these changes we make in the graphics layer are not considered by the transformable modifier. So let's instead do it like this. We apply this after the graphics layer, and we instead have to do certain calculations in order to move our new values into numbers we want to work with. For scale and rotation, this is actually pretty simple. The rotation can even stay like that. But the pan change is the tricky part here, because we in the end need to kind of rotate the translation of that pan change in order to still move into the right direction. So for that, how does that work? We want to first of all calculate the angle based on which we are rotated, but in radians. In case you're not aware, we typically don't calculate with degrees as values, but with radians, which is a more math-like value that is better for these calculations. And the formula for that is simply to take the rotation, multiply that with pi, so the number pi, and then divide this by 180 degrees. And with that angle value, we can calculate the cosine and sine by saying that's equal to cos, where we pass in this angle, just like the same for the sine, also with the angle. Because with those values, we can now calculate this rotated pan value. And I'll say something about that in a moment, but let's first of all write this down. Rotated pan x is equal to our pan change.x multiplied by cosine. And I'm really just typing math formulas here in order to calculate that, but I'll explain a little bit how we calculate that and why this works. Minus pan change.y multiplied by sine. And we have the rotated pan y, which is pan change.x multiplied by sine this time, and plus pan change.y multiplied by cosine. So in the end, what we want to achieve, if this text here, let me rotate that. Can I rotate? Let me put this again here. No, it's still the old version with the, where I had the transform at the wrong place. Let's relaunch this and show you what I mean. If the text here, for example, is rotated by exactly 90 degrees like this, and we drag to the right, then with our calculation, what we need to achieve is that this right drag, we transform into a bottom drag. Because if you move your head like this and rotate it, then moving this text to the bottom actually really moves it to the right side. And that's what we would expect. And that is what this rotated pan x and pan y here achieves, to translate that rotation here into a right drag in this particular example at least. However, that's not it yet. The new scale is also playing a significant role here, and this calculation is already correct. So we just calculate the new scale, simply clamp it in between those two values. But we additionally also want to make sure that we constrain this here in our parent container. Otherwise, we can move the text out of the box. So let's actually calculate the scaled width. So the actual kind of real width, because the graphics layer modifier doesn't really change the actual bounding box of the element, but it just changes the size or the scale of the underlying canvas. But if you would actually give this a background here, then the background would still exactly fill the bounding box of this element. And therefore, we need to internally kind of calculate the scaled width by using our child width, so the actual width dimension of this particular child, so how wide this text is, which we get in here, and we multiply that by the child's scale value. So if we scaled to a value of 2f, that means the actual width that we need to calculate with is also twice as wide. And the same thing we do for the scaled height, child height multiplied by scale. Now comes another complex thing. Let me put another text here. The thing is, we can't just take those visual bounds here in order to constrain these inside this parent container. That would be fairly simple. But as soon as we actually rotate our, as soon as we rotate our text like this, then we need to constrain this text in kind of an invisible bounding box, which goes actually like this. So a rectangle that goes through all these corners of this element, because if we move this here to the left side, then here we want it to stop. Actually, we wanted it to stop first because this here would exceed the top side of this canvas, of this image. And this is the next thing that we want to calculate, which I will call the visual width and height. So visual width is equal to abs, so the absolute value, always the positive value if it's negative. We take the scaled width multiplied by our cosine value plus abs of scaled height multiplied by sine. Same thing for the height. And again, I'm just applying math formulas here. For the height, we say sine, and we say also plus, but here we say cosine. So this formula here, after all, projects the rectangle's edges on the x and y axis. Furthermore, what we want is a scale offset x, which is equal to our scaled width minus our child width divided by 2. And I'll also say something about that in a moment, but let's also have the y scale offset, which is the scaled height minus child height divided by 2. Because if we now relaunch this again to show you this, I wouldn't have needed to relaunch it, but if we add a text and we scale this text, take a look at this top left corner here. If we scale this now, then this top left corner also moves. Even though we don't move the text ourselves, we just scale it up. But this is also something we need to account for. And that's exactly what this extra scale offset y and x does for us. So simply the scaled width, which is the entire width of this scale text, minus the child width, so the original width of the child, which is exactly the difference of the extra scale, divided by 2, because we obviously scale from the center in both directions, and we only want to we only extend the offset by half of that. The same thing we want to do for the rotation offset, since also, as I mentioned, the rotation changes the offset as well, even though we don't explicitly offset the composable. So rotation offset x, which is equal to our visual width minus the scaled width divided by 2. So same thing, same concept. rotation offset y, visual height here, minus scaled height divided by 2. And with all those calculations and values, we can now finally compute a minimum x value, a maximum x value, and min y and max y. Simply values, clear numbers in which our text is allowed to move in. So we have min x, which is equal to our scale offset x, plus the rotation offset x. We have max x, which is our whole parent's width, minus the child width, minus the scale offset x, and minus the rotation offset x. So here, for the minimum x, we simply take a look at the offset values from the scale and the rotation. That is, in the end, the minimum offset where this text needs to be. And the max x value is simply the same thing reversed, where we just subtract those values here from the right side of our image. Then we have the same thing for min y, same concept, just with the y values, rotation offset y, and we have max y, which is scale offset, actually parent height, minus child height, minus scale offset y, and minus rotation offset y. And then we can finally calculate the new offset for our child. So for the x value, we take the offset ratio x multiplied by parent width, that is the actual absolute pixel value. But additionally, we want to add the new pan change, not this one, however, but the rotated pan change, so that we still drag into the right direction. And not only that, but the new pan change, so by how many pixels we've moved, we want to rotate this based on the scale of our child. And this is now what accounts for always assuring the same movement. So that if we move our finger by 100 pixels, then our text will always also move 100 pixels independent of the scale. Because we multiply this pan, so how much we want to move this item now, by our scale. And then what we can do is we can say chorus in again, where we say, okay, the first value, so the minimum value, is equal to min of, min x, and max x. I had some scenarios where really large zooms or so broke this, because then the minimum value was actually larger than the maximum one. So this is the easiest way to account for that, by just using min of and max of. Here we have max, actually also min x and max x. And for some reason it says it wants a float, but we gave it a double. No idea why that is necessary, but can we simply say to float? Oh no, the actual x value here needs the float. Then let's think this is because we don't convert this angle here to floats. Let's do this. Yeah, if we convert pi to float, then the error goes away, because this bubbles down to the very bottom here of our calculation. So we can actually do the same here. Instead of pan change y, we say child scale multiplied by rotated pan y. And we have the same coerce in, just with the y values. Min y, max y, and min y. I think that should now be it. You can see, quite complex. And yes, of course, it also took me a while to write this code. It's not like all this math is suddenly in my brain. There was definitely a bit of back and forth involved with ChatGPT, with Claude, with my own personal consultants. But I hope this is still somewhat understandable. If these degree and angle calculations here with sine and cosine are new to you, well, I can make a geometry masterclass here in this course. But then that is something where you will find plenty of content on in the internet to understand where these formulas really come from. So I would say we give this another go and we relaunch our app and see if that works. There we go. Here, select the meme, add the text, and we can drag it around. And yep, here you can see we can't move past that one. And we can't move past the ceiling. We can't move here and we can't move here. And if we now scale this up, then you can see it's also considered here. If we rotate this, then we also can't move this in here. Perfect, perfect, exactly what we want. And now it's also fixed that we move in the right direction, and the text really moves there. And also the scale is accounted for when moving, so it's just as fluent as when the text is smaller. And we can then tap inside here. We can also give this multiple lines, line 3. And then this still works just as fine, like this. Not yet sure what happens if we type some longer text and we then scale this one up. Okay, that is not yet accounted for, that our text will wrap lines in that case. It's still something I would like to do, but yeah, we're of course not yet done with this app. In order to first fix this issue that when scaling up this text here, it should wrap lines, this is actually a fairly simple fix, which you can make here in the draggable container. Since if you remember, the moment we scale up our text, for us, the size of the text visually increases, but actually not the bounding box, because that's not how graphics layer works. Graphics layer will just scale up the underlying canvas, but the real absolute dimensions for this box composable will stay the same. And since for a meme text box, we pass down these max width and height constraints, which are in the end responsible for wrapping the text at the right position or with the right scale, these are the real composables bounds here. However, if we pass in the parent width and parent height, those are just dimensions here of our bounding box, but they don't consider our current scale factor in any way. So what this means is we could scale up our text by the factor of 2, so it's twice as large as the actual bounding box, which would still be somewhere here. And because it just considers this bounding box here for those constraints, it sees, okay, there's actually still enough space in order to fit this text in, because it doesn't consider the scale factor. And considering that is fairly simple. You just need to put this in parentheses and then divide this simply by the child scale factor. So if we scale up the child by 2x, then it's twice as large as the actual bounding box. So we need to divide by 2 here again. And the same thing for the height. Divide by child.scale. If we do this, there's still some edge cases where this would actually exceed the bounds here. Also when we type, it's actually super tricky and also questionable how we want to implement this, because I don't think there is no single true way of implementing this with perfect UX. I will show you what I mean. If we tap inside here and we now extend this a little bit, if our text is here and not move to the completely left, then technically it can still exceed this here a little bit, but at some point you can see it will wrap, because then it exceeds these constraints that we have here. Also, if we then tap outside here, now it's inside the bounding box the moment we drag it. And I think this is definitely decent, because if we now actually scale this up, then you can see now the moment it exceeds, or it would exceed our screen's width, it will simply wrap lines. And this is exactly what we want here. Technically, as I mentioned, to fix this issue, that if we type something here, so it's not completely offset to the left, but there is some offset, and we type something here, that it wraps lines the moment the text would exceed the bounds here while typing. You could calculate that in the end by taking the parent width and subtracting the current offset here to then set the max width technically to just the width of our bounding box here, of our child. I've tried implementing that and it also worked, but I felt like it was a little bit weird UX, because also if you type this here at the very left side, then there was maybe only one letter visible. So this wasn't so nice, which is why I decided to stick with this approach, which will definitely let someone use this app nicely. What comes next? Well, of course, we still have to implement our export feature. But before we get to that export part, which is the biggest remaining part of this app, obviously, let's implement all the smaller little missing features, like the back button on the meme editor and the confirmation dialog, so that you need to confirm leaving a meme or editing a meme if you haven't saved it yet. For that, let's first of all go to our meme editor here, because this is the place inside this outer box where we can place our icon button, the go back icon button at the top left corner. So specifically inside this block here, we can have an icon button, and when clicked, we can say on action, meme editor action, go back click. We then say, we give this a modifier of modifier, and we align this in the top left corner. Alignment, top start. And inside here, we can then set an icon for that by saying icon, choose an image vector, which is equal to icons default back. Arrow left here, and that one is deprecated, but we can Alt enter here to replace this with this non-deprecated variant, the auto mirrored filled arrow left, and then you can see it works just fine. Content description here let's just set this to back. And then in order to also account for this change, this is something we don't want to handle in the view model, because going back is something that involves our nav controller. Nav controller is something we don't want to have in the view model, since it's coming from a composable from our nav host. So let's instead go here to our meme editor screen, and we want to bubble this action up as a normal lambda. So on, go back, or just on back click, just a plain lambda. And then here in on action, we need to intercept those actions, specifically the go back action, simply via a when branch, where we say, okay, when that action is meme editor action dot on go back click. Then we invoke our callback. Otherwise, we ignore this event because we send the remaining events, of course, still to our view model, just like that. So for go back actions, we send this back, or we bubble this up here to our navigation route. So command click here. We need to implement this on go back click. And here we can simply say nav controller, navigate up. So we simply pop the backstack. This is something we don't want to do just like this, because we want to have the confirmation dialog visible. And yeah, actually in that case, we do want to send this to the view model. So what I want to do is I want to go to meme editor view model. And here we somewhere have the on go back click. Here, let's just say show leave confirmation dialog, alt enter, create this function. And well, in which case do we want to show this? I would say we show this if there is at least one meme text added, because that means we made some changes that we perhaps didn't save. So if our state value meme text is empty, that means we can safely navigate away when we click the back button. Let's rather rename this to better reflect this to something like attempt to go back. And well, now there are two options how we could implement this, because now the view model needs to technically trigger a navigation action here. In my longer courses, I typically handle this with so-called one-time events. So simply kind of just like the action. So we bundle certain types of events the view model needs to tell the UI about in a sealed interface. And the view model can then notify the UI about something that should only be handled exactly once, like a navigation action, and not something that is like state, where the value should be re-emit, for example, after a screen rotation, where the UI would simply subscribe to the state again, and therefore would get that value and possibly handle it. However, in this rather small project here, I still like to handle this with state. So this means I want to extend our state with a value that we call perhaps is done editing. So something that just tells us in the UI, okay, let's pop the backstack and navigate back. Since in this particular case where a state decides about us navigating away, that's kind of a special case, because then the issue that I've mentioned, that the state could re-emit after a screen rotation and therefore perform another navigation transition, that can't happen here, because if, as a result of this value switching to true, we pop the backstack, the view model is also destroyed, so our meme editor view model, which is the case when the corresponding screen is popped from the backstack. Well, then the view model state is of course destroyed with it, and therefore there would not be anything that is re-executed here after a screen rotation. It would be a different thing if the view model is not destroyed. So for example, if you navigate somewhere, so you don't pop the backstack, but you just push another destination on the backstack, or alternatively, if you show some kind of error snack bar or so, where the screen is also still visible, but you also want to do this just once. In these cases, check my longer courses, check the KMP bundle down below, and that is where I'll teach that. For now, let's rely on is done editing and go back to our meme editor view model, because here, state values meme text empty. If that's empty, that means we can safely navigate away. By setting state is done editing to true here in this case, and this will then trigger a back action in the UI. However, if there are meme texts, then that means we want to update our state, and we set is leave without saving to true instead. And this will then show our leave confirmation dialog. That means we still need to implement on confirm leave without saving. So confirm leave, yeah, just confirm leave, I think. Alt enter, create this function. And in here, when we click on the leave option in the leave dialog, that means the user wants to dismiss the changes. Then we can also just update is done editing and setting this to true. Maybe I think a better name would be has left, since is done editing could also be interpreted as something like the user has finished editing a text and taps outside. I like has left more, so let's simply rename this here, has left editor. Something like that. Then on dismiss leave without saving, so this means the confirm leave dialog is visible, but the user taps outside to simply dismiss the dialog. Dismiss confirm leave dialog. Alt enter, create this function, and in here we will then update our state, where we simply set is leaving without saving back to false, so the dialog won't show anymore. Cool. When we go back, that is something we've already done. So here we show this leave dialog. Awesome. So we now just need to build this dialog that it also really shows when this state switches to true. And we need to rely on listening to changes of this action in order to really navigate back. So in our meme editor presentation component, I want to, first of all, create a more generic confirmation dialog composable. So for any type of dialog where we can confirm something, let me add that to Git. And I first of all want to create some bundled config for this dialog. So something like confirmation dialog config. So where we just say, hey, that's the title text, description text, and so on. So val title, val message, so the actual body of that dialog. We have the confirm button text, cancel button text, and lastly, perhaps the confirm button color if we want to change that in form of a compose UI graphics color and setting this to null initially. Then let's have a composable that accepts this config, so confirmation dialog, where we pass in the config, and we then get back on confirm action and on dismiss action. Inside here, we can then make use of the alert dialog composable, where we need to pass an onDismiss request lambda. So this is in the end a lambda that is triggered when the user taps outside the dialog. Here we simply want to bubble this up to our onDismiss lambda. Confirm button. This is now the composable for the actual confirmation button, how it should look like. We can simply use a text button here, so simply a clickable text. And when we click that, we say on confirm, and then we can also style the text a little bit. So we say the text here is simply our config.firm button text. And the color, if we've set that, is config confirm button color. And if that doesn't exist, we can default to something like the error color. So we just make it a destructive confirmation action by default. We can then set a dismiss button as well. So this will simply be the cancel button. Also make this a text button. We can simply copy this. This will trigger on dismiss. This will trigger, this will pass the what is it called? Cancel button text. And the color here won't be dynamic, but we will just pass in our secondary color. Furthermore, what else do we need here for this dialog? The text, so the actual body content of this dialog. Here we can pass in a text, which comes from the config. So message. The text style here can be our material theme text style, typography, body medium. And lastly, let's set the color to material theme, color scheme on surface. So typically the dialog background color is the surface color. And if you want to draw content on top of that, then, well, we will use on surface. Lastly, I think it's called title. Yep. Let's have a title text, copy, paste that, pass in our title text. This can have the font style, headline small, and also on surface as the font color. And let's lastly also forward our modifier here. And I think that's it for the more generic confirmation dialog composable. So you could use this for any type of confirmation dialog now. And when showing a specific confirmation dialog, well, we just pass in what's dynamic. So I would say in meme editor screen here, down there, at the very bottom of the screen here, we will check if state is leaving without saving, because then we want to show this dialog. Then we show our confirmation dialog. We create a config, confirmation dialog config. And here we can really pass in which specific title, message, text we want to have for this one. The title can be a string resource, res, string, confirm or leave editor title it's called, message, let's copy paste that, leave editor message, confirm, or what is it called, confirm button text is leave, so just the action leave. We have the cancel button text, this will be cancel, and for the actual color, confirm button color, I would like to pass in our secondary color. Material theme, color scheme, secondary. Then what else do we need? On confirm, obviously. This means we send an action, meme editor action, on what is it called? On confirm leave without saving. On dismiss will also trigger an action, meme editor action, on dismiss leave without saving. And now if we trigger that, if we confirm, in our review model, we switch to has left editor true. And the moment this property switches to true, we want to perform the back navigation. This means in our meme editor, we need to scroll up, and we don't want to trigger our back action immediately when we click the back button, since we first check in the view model if we want to even show the dialog. So I would say we go back to what we had previously by just forwarding all actions, but then having a launched effect in here. So we listen to changes of this has left editor state. And if so if that is true, then that means on go back click, and we rather rename this to on back, because here we didn't necessarily trigger a click. And when we navigate back, then here in our meme editor root, this will make our nav controller navigate up. And the moment we navigate up, this backstack entry here is popped from the backstack. So that will also clear the view model. Therefore, the state is destroyed and we don't have any issues with listening to the state and navigating as a result of that. But that's really only true when doing this for popping the backstack, from really removing a screen from the backstack. So this means if we relaunch this, this should hopefully work. Those weren't too complex changes right now. Clicking the meme, adding a text. For some reason, these texts here are also a little bit weird looking. I'm not sure if this is because I'm in light or dark theme. Let me quickly check that by going in here. I am in dark theme. Okay, maybe we need to configure the theme a little bit differently, or set the color to, just a white color for this button. Let's quickly do this. Bottom bar, so simply here for this button, we want to say colors is equal to button defaults, button colors. Container color can stay as it is, but the content color can be something like color white. Since we only support dark theme, we can do it like this. Relaunch, take a look on running devices. And now, now that looks better. If we now simply, okay, that's actually not the back button that I wanted. But if we now click this, we can go back without any issues because we haven't added any text. If we click add text and now go back, then our leave editor dialog is showing. Perfect. We can dismiss that. And if we click leave, then we navigate back. Cool. Something to also note is if we add a text and we make that back gesture, right now we go back normally. So here we also would want to show the confirmation dialog. This can be done by going to meme editor, and here, or actually here, I think this better fits to the screen. We have a back handler. So a back handler lets us simply intercept such back gestures, because if that triggers, we want to trigger our action, meme editor action on go back click. And in here, we don't want this to be always enabled, but only if we are not inside the confirmation dialog. Because if we are in the confirmation dialog, then the back gesture should normally just lead to the natural action kind of by closing the dialog. We also need to opt into the experimental API here without enter. And then we can also listen to these back gestures and actually trigger our dialog. If we go in here, we add a text, we now go back, well, then our dialog is shown. We can dismiss it. Also, if we now go back here, then the dialog hides instead. And if we then click leave, then we go back. Cool. That also works. And we make that. I think we can get to the more exciting part here, which I think many of you are waiting for, which is the meme export. So this is a bigger thing, of course, to implement here. And I think it's important to first understand how this is actually going to work. So let's take a look here. If we add some text, then, well, right now we can drag these around, we can scale these up, we can edit these, we can rotate these, we can do whatever we want, and it looks fine here in this editor. But exporting is a different topic. In the end, what we have here are just plain composables that we can drag around right now. But well, as you can imagine, it's not as simple as just telling the Kotlin or Android or iOS, hey, here's a bunch of composables, please give me that as an exportable image. No, it actually won't work that way, because if we think about such more or less custom image exports, then that always works by, first of all, creating an image with an underlying canvas, or with a canvas that gets rendered on top of the image. So this means we will use this existing image as a base, but then we have the option to manipulate and change the canvas on top of that image. And a canvas is really just a rather low-level surface to render stuff on. So a canvas can be used to render other images on, a canvas can be used to render texts on, a canvas can be used to render certain shapes on, a circle, a square, rectangles, whatever you want. But we, in the end, need to take a look at all these texts that we've added here to the meme, take a look at all their transforms, their offset, their rotation, their scale, remember those values, and then replicate the positions, the rotations, the scale of all these texts at exactly the same positions in the underlying canvas. So we just kind of redraw these texts on a separate canvas with this image being behind that. And that is something we can then export. On Android, that is where I want to start doing this, because this is now something that is definitely platform specific. Since here now the file system is involved, here the platform specific canvas is involved, here image processing is involved, and that just works differently on Android and iOS, which is why we need to implement this twice. And in Kotlin Multiplatform, that works with expect actual. Not sure if we've already used expect actual here in this product. I don't think so, to be honest. No, we didn't. So what I will do is I will go to meme editor, domain, and first of all, I won't yet make use of expect actual, but I will create a meme exporter interface. And let me first write this off, and then it'll make sense. Inside here, we want to have a suspend function, so we will make use of coroutines, since exporting a meme, saving something to a file, that is something that can just take a little moment, and we want to execute this on a background thread in a suspending way. Export meme is the function called, and what will this function get? We now need to think of the common parts for exporting. So what are really common inputs that we have here in our common main source set for both Android and iOS that both platforms understand? Which inputs are necessary to export a meme that we feed into this function, where we can then have platform-specific implementations that interpret these inputs just differently depending on the platform. And that is, on the one hand, of course, the image itself. And if you want to represent certain file data in a platform-independent way, well, then the most fitting type of data is simply a byte array, because a byte array is, as the name says, really just an array of bytes, so of numbers, and that's obviously something both these platforms understand. So we, on the one hand, have a background image bytes, which is a byte array. So this will be the byte array of the actual underlying resource, so of our real meme template. Then we need to pass in our meme text. So, of course, this exporter needs to know all those meme texts together with their positions, rotation, scale, where they should actually be positioned on that background image. We need to know the template size, form of an integer size, so how big the actual image actually is that we want to render these texts on. We could pass in something like a file name to which we want to save this file, simply have a string, but here we can also default this to something like meme, and then reference the current time so we get unique values, or perhaps also UUID would be sufficient here, UUID random toString. Alt enter to opt into this here at the file level, just like this. And then we say .jpeg. Here it makes sense to save this as JPEG and not as PNG, because a PNG supports transparency, JPEG doesn't, and memes can't be transparent by definition. So with the JPEG, we overall get a smaller file, since there's just less information or less options that need to be saved here. Furthermore, and the last thing that I want to pass here is a so-called save to storage strategy. That is a separate interface that I will create. Save to storage strategy will be an interface, because technically there are multiple different strategies or ways to save something, to save a file, to save an image. So you could imagine saving that to external storage. So something where you really have this image appear in your gallery automatically. You can save this to your cache directory, to just have a temporary file that you can then share with other apps, to forward this to WhatsApp, to your Google Files app, and save it there. That is what we'll do. You could save this to the phone's internal storage on Android, so your private sandbox storage, which is not public to other apps, but it would be saved persistently. And what I want to do, we want to implement with the save to storage strategy. So all this strategy will do is it will expose a function to get a file path based on our file name. And this can then return a string as the file path, because then we can also have platform-specific implementations that just return the right file path for the right type of storage, which is just a very flexible approach. So in our meme exporter, we can pass this here, save to storage strategy, just like that. So this in general is our meme exporter, the class, or right now the abstraction, but it will of course have an implementation which will be responsible for exporting a meme and really implement this function. Since we need to use this class in our view models, in our presentation layer, that is the reason I've put it in domain, because domain in this type of architecture is the innermost layer. Every other layer is allowed to access domain, but domain is not allowed to access any other layer. And since exporting a meme is technically data-related logic, so something we want to have in our app's data layer, we need this kind of intermediary abstraction, because then presentation can access that domain interface, and the implementation can sit in data, because data is also allowed to access our abstraction, but domain would not be allowed to access data, or presentation would not be allowed to access data directly. So let's take a look at how that works. We could call this platform meme exporter, because it's platform specific, and we need another name that is not meme exporter already. Let's make this a class now, since this will be an implementation. Then this will also just take this suspend function. Actually, we need to implement our meme exporter interface and then override this function. But how are we going to now implement this? Because we are here in our common main source set, where we can only access real Kotlin multi-platform code and libraries. But as I mentioned, exporting a meme is platform specific. Here for Android, for example, we need to access the bitmap class. And bitmap is something, well, we have this here from Coil, but this is not the bitmap we want to work with. We want to work with the Android graphics bitmap. And that is something that we would have access to here in Android main, for example. So if we go in here we would certainly be able to type bitmap and we get the Android graphics bitmap because we are in our native Android side of the code base, but here we aren't. So this is another place where we can really implement this function. And in order to really achieve this, to have these platform-specific implementations, Kotlin Multi-Platform gives us the so-called expect actual mechanism. It works comparable to how interfaces work. So on the one hand, we have an expect definition. So that is something we put in the common code. What is just the functionality that we expect a certain piece of class to have? And then we have actual multiple implementations for each platform. And for each of these implementations, we can then stick to the platform-specific APIs and source code. So just like with an interface, we can have multiple implementations. With expect actual, we can also define the expect variant, which is kind of the equivalent to the interface, and then the actual implementations, which is equivalent to implementing such an interface. So instead of actually implementing this function here, I want to get rid of the body and make this an expect class. And you will see that this gives us an error because now it actually wants us to enforce implementing the actual variants for all of our supported source sets, for all of our supported KMP targets, so Android and iOS in our case. And that's what we can do by hitting Alt-Enter. On the one hand, we can add this compiler warning here to get rid of the warning, but then hitting this again to create the missed actuals. If we hit Enter here, and we start off with Android main, then we suddenly get an actual class, platform meme exporter, which, however, is now placed here in Android main. And this, as you've just seen, is the place where we can now access bitmaps and other Android-specific things in order to work with that and define how exporting a meme works for Android. So let's see how this works. On the one hand, in order to really work with the file system and all that stuff, you for what you do, that we need the context on Android, since that is kind of the bridge between your app and the system. And since we are in the Android-specific source set here, we can perfectly make use of the context. However, there are still certain common parts for our final calculation here, how the bitmap is going to look like between Android and iOS. And these common parts or common calculations are in the end just plain Kotlin calculations. So for these, it makes absolute sense to put these into a class inside our common main source code. For example, in presentation, since that really calculates UI-specific values, I would say we put this in presentation util and make this something like a meme render calculator. This can really just be a plain class where we pass in the density as a float, so the display density, since that will be necessary to calculate the necessary values later on for our platform-specific exports, since drawing something on a canvas is always working with pixel values, but rendering something on our screen in our composables is typically using DP values, so it relies on the device's density. So we need a value to convert between these two, and that is what we'll pass in here. Furthermore, we can also create a companion object with two constants. On the one hand, a private const val, which we call text padding dp, is 8f, so 8 dp here, but I'll represent that as a float. And we will have a private const val for the stroke dp, which is 3 dp. Because in the end, if we think about it, and this will also be a main role of this meme render calculator, here, if we've selected this text, then technically we consider, or we add a little bit of padding here, which is 8 dp. There is a little bit of stroke width for this text being applied. And if we wanted to look consistently also in the export, so that our text ends up at exactly the place where we also dragged it here on the canvas, we need to also in the end subtract this text, or at least know the padding, in order to later draw this text not at the left corner of our UI, plus the actual text padding, so it ends up at the same position. And the same thing we need to know for the stroke width, so that the final export will also use the same stroke width as we use in the UI. So that's what we'll do in this render calculator. So just kind of extract all the common calculation logic here and forward just what needs to be platform specific then to the platform specific implementations. On the one hand, I want to calculate scale factors, for which we can actually create a little helper class here, data class, scale factors, which will really just give us the scale in X direction
the scale in Y direction, and the bitmap scale, because our final bitmap output may not need or may not be actually the same dimensions as here. It may be a higher resolution image. So we first of all need to think about, depending on our existing scale, how do we need to scale up the bitmap based on these scale factors. So here we get passed in the bitmap width, so the width of our final output image, which is an integer, the bitmap height, which is also an integer, and we get the template size passed in, which is an integer size, so the actual size of our meme template. Then in here, we can calculate the scale x by saying, okay, if the template size dot width is actually larger than 0, so there is a valid width, then we can say bitmap width to float, and otherwise we say template size dot width, and we divide that by template size dot width. That gives us our scale factor. So if our bitmap width is, for example, 1000 pixels and our template width is 500 pixels, well, then that gives us a scale x factor of 2. So we need to scale up the template size here by the factor of 2 in x direction to get to the bitmap width. Otherwise, we just say a scale of 1 in case it's an invalid width. Same thing for the y value. In our case, the scale here will be constant, so in both directions, but it could be that the bitmap does not have the same aspect ratio as our template, and then we would also need to scale this up correspondingly. So we say scale y is the template height, bitmap height divided by template size, dot height, and then we can say the bitmap scale is simply the average of those two. So we add scale x to scale y, and then divide this by 2, which is simply the value in between those two. And then we can say we return this as scale factors, which we also need to return here. Scale factors, oh no, that's the wrong scale factor. Scale factors, plural, forward our scale x, scale y, and the bitmap scale is bitmap scale. No, scale. Next up, I want to create another little data class that bundles relevant values for us. Let's put this here, which we'll call a scaled meme text. Make this a data class. And this will involve all the information that our platform-specific renderers will need in order to have it as easy as possible to draw these texts at the right positions with the right scale and rotation. So on the one hand, they of course need to know the actual underlying text that needs to be drawn. They need a scaled offset. So we will already consider all of our scaling that we've done in the canvas. And we just want to give the platform-specific renderers a final position where to draw something, a final rotation where to draw something. We want to also calculate the font size already, because technically we have a static font size, but since we can scale up the underlying canvas of the text, the font can appear larger, but the font size I think is always 36 pixel, 36 dp here, or sp for fonts. And we still need to pass a real font size to the canvas in order to technically scale up the text, and that is what we'll consider with a scaled font size in pixels. Stroke width, also as a float. We need to know the constraint width, so we also implement proper wrapping for the final text. We need the text padding x as a float, text padding y as a float, since that also plays a role for the final export. We have the rotation as a float in degrees, the scale as a float, and lastly, I want to pass in the original text, which is a meme text. So with all the original properties, in case we need to reference those. In our meme render calculator, we can now have a function here, private function, calculate scaled text box or meme text, which gets passed in the meme text. Let's again call it meme text. It gets the scale factors passed in for the bitmap and the template size. And it will then give us a scale text box, scaled meme text, for all these properties that we've just defined. So here we now need to perform a few calculations. First of all, let's extract the scale factors here. So scale x, scale y, and bitmap scale from calculate scale factors, bitmap width. Actually, this function is called from somewhere else. Let's pass in the scale factors here. We've passed to this function. Now, first of all, we want to calculate the scaled offset. So we simply consider the scale that we've applied to a particular meme text along with the offset ratio and offsets from this meme text in order to then get the final absolute offset for this particular text on the final resulting bitmap. And this is working as follows. We will construct a new offset where the x value is equal to our meme text dot offset ratio x. So this is again value between 0 and 1, and we need to multiply that with our template size dot width to get the offset in pixel values. But we now need to multiply that with our scale x. Because right now in the normal absolute offset, our scale is not yet considered. And as you've learned already, scaling up the text will also change the offset. Same thing for y, offset ratio y multiplied by template size.height. And this one gets multiplied with scale y. Then we want to next calculate the text padding, or the content padding here for this meme text in kind of bitmap coordinates. So we first of all want to know the text padding in pixels, because we pass this in as a dp value here. So this is a dp. And to first of all convert this to pixels, so something our canvas understands later. This is equal to our constant text padding, simply multiplied by the platform or by the device's specific density. And therefore we can calculate a text padding bitmap in x direction, which is our text padding x multiplied by scale, because here again, the scale can technically, visually at least, increase the padding, even though the underlying real padding stays the same. That's why we need to multiply this with the scale as well. Same thing for y, just that we multiply it with scale y here. We then want to have a scaled font size, which is in the end something where we need to take the original font size, meme text.font size, multiplied with our bitmap scale, because as I mentioned, if we scale up our text, then the font size also stays static, always 36 sp, but due to the increased scale, we obviously also need to calculate a scaled font size for the underlying canvas. So we say, hey, that is your final font size that looks identical to our fixed font size plus the scaling. Next up, we can calculate our stroke width for the final bitmap, which is equal to our stroke width dp multiplied with the density, because again, this is technically a float value that we need to convert or interpret at least as a dp. So this would be the stroke width as dp, but in pixel values, and also multiplied with our scale x. And lastly, we need to calculate our constraint width. So we also properly make the text wrap in the final output. So we say padding dp is equal to our text padding dp multiplied by 2, since the padding is obviously applied in on both ends. So we need to subtract this entire padding dp here from the final text output. We then can calculate the padding in pixels, which is padding dp multiplied with density. And then finally, we can calculate the constraint width. So the allowed dimension in which the text is still allowed to expand. And when it exceeds that constraint width, it will simply wrap lines. And that is template size.width divided by our box scale, meme text scale. And that is our template size.width divided by our meme text.scale, so the original scale. We then multiply this with our new scale x factor that we want to consider on the bitmap. So again, this is the scale factor between our meme template and the resulting bitmap. It's a different one than this. This is the scale factor for this particular meme text. This is the scale factor for the output image. And then we simply subtract our padding in pixels multiplied with that scale x factor. So all this really does is it uses as a constraint width our entire width of the resulting bitmap in pixel coordinates with all scale factors considered, but it subtracts the padding from both sides. So here our padding is considered twice, so that we really just have the minimals, the minimum spacing that is necessary in order to render the text, and that is what's returned here. We can convert this to an integer with round to int, and then say coerce at least 1, that this at least has a positive value, because otherwise this may crash. And then we can finally return this as a scaled meme text, where we just forward this all. Meme text, text, scaled offset, scaled font size, scaled, it's called pixels, stroke width, stroke is stroke width, constraint width, text padding on the x direction is text padding bitmap x, text padding y, text padding bitmap y, rotation is, that stays the same from our meme text rotation, scale, meme text.scale, and the original meme text that's also attached that like this. Here scaled font size, that is still as a text unit, but we want this as a float here, as a pixel value in this final scaled meme text helper. So we can say, we actually need to create a little helper function that converts SP to pixel values. This is not as easy as just multiplying this with the density value, since SP is based on the user's font size preference. So if they say in the system settings, I want to see a large font size in all my apps, then this is resulting in a different thing than just multiplying this with a density. So let's go to presentation util, have something like SP to pixel. So just a helper function, since that is platform specific here as well. A helper function that converts pixels, SP to pixel values on each platform. Expect function, so here again, expect actual mechanism, where we say we extend text unit, so an SP value, and we say to pixel, which returns a float, so a real pixel value. Alt enter here to create the missed actuals. First of all, for Android. Here we now need to define how converting an SP value to pixels works on Android. This is pretty simple. We just say we get the so-called display metrics from resources. Here, Android content resources. Get system, display metrics. And then we can say we return typed value, apply dimension. So we want to perform a conversion here after all. Specifically, typed value, complex unit SP. So that is what we want to convert. Where the actual value here, what we want to convert, is this. So the text unit, but it wants this as a float. So that value, which is simply the SP value, but as a float. Not converted yet as a float, but just interpreted as a float. So if we have 36 SP, then this would simply be a float that says 36. And the metrics, well, that would be our metrics that we've passed here. That's how this works for Android. Let's go back to the expect function. Alt enter to create this for iOS main as well. And here this is even simpler. We can just return this, that value, so the float representation of the SP value again, multiplied by UI screen, main screen, scale to float. And that's how this works over there. Cool. Now we can use this function in our common code because we have platform-specific implementations. So here, we can simply call to pixels now with our own custom helper function. All right. Next up, now that we have this important common calculation logic here in the common part, we can share this class between the Android platform meme exporter and the iOS platform meme exporter, so that we don't need to calculate this twice and we really just do what needs to be done in a platform-specific fashion. Here, for the platform meme exporter, this is our common class, but we want to go to the Android class, the actual implementation now. And here, we can now create our meme render, let's call it meme render calculator, which is equal to a new meme render calculator instance. And the density here on Android is coming from context, resources, display metrics, .density. All right, let's get to the exciting stuff and implement this export meme function, which will rely on a few helper functions here. First of all, meme, what we want to have in here is on the one hand a bitmap from Android graphics, null by default. And we want to have an output bitmap, also null by default. So this bitmap here is the meme background image bytes, but loaded as a bitmap. So simply our meme template drawn on a bitmap. And the output bitmap, well, that will be the output bitmap. So with our text rendered on top of the original bitmap here. I'm creating these as vars because on the one hand, I want to make this meme with context block where we say dispatches IO. So here we now are about to save some files. So we want to make sure that we execute this on a background thread. So we fully make use of Kotlin Coroutines here, that this function is also called main save. Main save means that it's safe to call this even from the main thread, which it is if we immediately switch to the right dispatcher here. But then in here, I want to have a try, catch, finally block. Because in this try block, we will now attempt to work a little bit with these bitmaps, but in case something goes wrong, or in case that everything succeeded, we want to just make sure that both these bitmaps will be recycled and the resources will be properly freed up. Same thing for our output bitmap. So in the try block, we can first of all load our input bytes here into a real bitmap. So into something we can work with, that we can also draw something on. So we say bitmap is equal to bitmap factory, decode byte array, that is how we take a byte array, and interpret that as a bitmap. Background image bytes. The offset is simply 0, so this is referencing how many bytes you want to skip. We don't want to skip anything. That is the entire bitmap here. And the length of the byte array is simply background image bytes, that's size. Now this is just our original bitmap, so the meme template as a bitmap object that we can now work with. However, it obviously doesn't yet include our text. And that is why I want to create a helper function here called render meme, which will get the background bitmap passed in. It will get our meme texts passed in, so all meme texts we want to draw there, and it will get our template size passed in as an integer size. And will then return a bitmap, but this time with all the texts drawn on top of it. By default, such bitmaps are not mutable. So what we need to do is we need to convert this here, and let's make this yeah, let's make this suspending as well, because this is probably better to be executed on our default dispatcher, since the default dispatcher is meant for CPU heavy things, which, for example, copying a bitmap and making it mutable is, which also is the case for maybe iterating and processing a bitmap to iterate over all different pixels in a byte array. That's also CPU heavy and doesn't relate to anything I/O specifically. So we have the output here, which is equal to our background bitmap, but we say copy, where the config of the bitmap, need to pass it like this, bitmap config ARGB and 4 times the 8. That's just the color format that is supported here. So we simply want to have an RGB format and is mutable. We set to true now. So we can really change this output bitmap. This one here would not be changeable by default. And changing means we can simply change pixels. We can say this pixel is now not black, but it's red. And we can also draw things on top of this bitmap, like our text. We then want to declare a canvas object from Android graphics. And here we can pass in a bitmap. And this bitmap will serve as the background for this canvas. But now that we have a canvas, with a canvas, we can suddenly draw something on top of that. We can draw a path, an arc, another bitmap. So if you would want to also support drawing around images and importing these here on top of the meme, that would also work by just drawing all these bitmaps separately on the canvas. It's a cool homework assignment. We can draw a certain color, a line, whatever you want, but that's not what we want to do yet. We first of all want to get the scale factors for that particular bitmap, and that comes from our meme render calculator, calculate scale factors, and the bitmap width is background height, template size is template size. And then we can calculate our scaled meme texts, which is now coming from our calculate scaled meme text function, just for all these meme texts. So meme texts map, so we simply map all of those to meme render calculator, calculate scale factors, bitmap width is background width. Oh no, not scale factor, sorry. Is that a private function? Let's make that public. Calculate scaled meme text, this one now. Meme text is simply it, so the current text we're iterating over. Scale factors is our scale factors from before. Template size is template size. And now in the end, for all these scaled meme text values, we want to iterate over these. And so for each scaled text, and now we want to have a function, something like draw text, that takes in our scaled meme text, as well as our canvas. So for each of these sets of values for each scaled meme text, we now need a function that really draws that text on top of our canvas here. So we can implement that here. Alt-Enter, create this, not extension function. Okay, let's write it manually. Draw text, we have the canvas, we have the meme text we want to draw, and then that will work. And here after that, we can return, or simply return the output like this. Then we don't have any issues here. This is an issue because it should be a scaled meme text. So now we need to figure this out, how the important part of the logic needs to look like. So how we specifically take this set of values for one single text, and how and where this needs to be drawn on this underlying canvas. And the thing is, here we now need to load the actual font, the font family, from our resources. But in Android main, we don't have access to our multi-platform resources. So here we have impact TTF already in Compose resources and common main, but we actually need this, copy this here in RAS of Android main as well. So here we want to create a new resource, Android resource directory, select font, click OK, and paste this font here as well, so we can load this here for this particular text. And this works via val impact typeface is equal to resources compat get font. We pass in our context to load this. The font RAS ID, here on Android it's not RAS, but just R. Wait a little moment, and then it should appear here as an import. Yep, import your package name, not any of these other R's, font, and then reference impact. And if that for some reason doesn't exist, shouldn't happen here, since we've included it as a resource, then we can say the default typeface is typeface here from Android graphics, default bold. And what we could technically take our canvas now and call the draw text function to draw text somewhere. This is a bit too easy. We of course also need to configure the styling of this typeface, since it needs to match exactly what we have in our meme editor. So in the end, we want to give it a stroke, we want to give it a fill color, we want to give it a certain font size. And that is what we achieve with a paint object in the plain Android canvas. For example, by saying stroke paint is equal to a paint object, where we can set a flag to anti-alias. So it will simply be a little bit optimized and not so edgy. and then call apply to configure this specific paint object that will now just be used for the stroke part. So we can set the style to paint, style, stroke. We set the stroke width to the stroke width we got from our meme text. Meme text. That is why we pre-calculated those values. So we can simply forward these here. Text size here, this is a pixel value, so float is our meme text scaled font size pixels. So here we don't need to perform any SP to pixel conversion anymore, since we did that in the common part already. The typeface is impact typeface, and the color of the stroke should be color.black. Same thing now should be done for the fill color. So fill paint, style should be fill. I'm actually curious. It seems like we could also use fill and stroke. This is something I'm not prepared for here. It's something that you could try. I don't want to freestyle this here. This would be too much experiment. But apparently for the Android canvas, there is an option to draw both fill and stroke together. I won't do this here. So for the fill paint, for the inner part of the text that is rendered in white, text size will stay the same. We won't have a stroke width for that part. The typeface stays the same, and the color here is white. And with these two types of paints, we can now create a stroke layout, so a layout in which we can give the text certain bounds and in which it can then also wrap lines when necessary when giving it our constraints. And this works with static layout.builder obtain to create such a layout. The source here is a character sequence or text, meme text.text. The start, so the start coordinate in X direction is 0, so the start of the text, and the end is our meme text.text.length. So it's actually the length of the text for which we want to render this. So we just want to render the whole text. The paint here is a text paint, which we can create and then pass in our stroke paint. And finally here, this width is now the constraint width. So we say meme text constraint width that we've pre-calculated. And then here inside this text layout, we can say set alignment, since we want to center our text, which is layout from Android text, alignment, align center. We want to set included pad to false. Set some fonts by default have some extra padding. Set not apply to the composer, but to the font itself, and we don't want to include that extra padding. We just want to give this text the minimal space it needs in order to render everything. And then we can say that build to create the stroke layout. Same thing for the fill layout. So let's have a fill layout. This will also render the same text with the same length. Here we pass in the fill paint, and that way we have two layouts that we can now use to draw. Furthermore, we want to calculate the text height. So the height the text will occupy, which is simply the height of our stroke layout. We want to calculate the text width, for which we need to find the longest line. So we don't simply want to say the stroke layout width, because the constraints are changed here in width direction. But what we want to do is we want to say a range of 0 until stroke layout dot line count. So we simply iterate over every single line of the stroke layout, depending on how often our text will wrap, and then say max off or null stroke layout get line width of it, and otherwise default to 0f. So what happens here is we iterate over every single line inside the stroke layout of our text and find the maximum of the line width inside that stroke text. So inside our meme text after all. So we just find the longest or the widest line after all in our text, and that is obviously the width of the text. Then here we again need to consider our actual padding that we've added in the editor, so that we really end up at the same coordinates as in the editor. So we say box width for the actual box that gets drawn is our text width plus our meme text padding x multiplied by 2 for both sides, and box height text height plus our meme text padding y also multiplied with 2. And something we want to do, you will see in a moment why, is the center x coordinate of the text, which is meme text dot scaled offset dot x plus our box width divided by 2. Same thing for y. No worries, I will explain this in a moment. Here box height. The thing is now, by default, the pivot when now applying these transforms, so we of course need to apply the scale, the rotation, the translation. By default, the pivot is in the top left corner of the text. If we take a look here, the pivot is here. That means if we would rotate the text and apply a rotation transform, it would rotate around this point here. However, then the text would rotate somewhere here around this coordinate, which is what we don't want. So what we instead do is we transform the text temporarily, just for our canvas transformations, by taking the center x, subtracting this here. That's a bad example. Let's put the text here. Let's say this is our pivot. Now we've calculated the center x coordinate, which is here. So we temporarily changed the offset of the text here by this center x coordinate. So we end up here. Same thing for y. So in the end, we've moved the pivot to the center of the text. And if we now rotate it, it has exactly the same look and behavior as in our text, so that it rotates around its center. And this is something we can achieve by temporarily moving the text here. And after having done our rotation transform, we can then again shift it back to the original position. And that works by saying canvas translation. And we want to say we translate it by center x in x direction and center y in y direction. And in here in this block, we now have a bunch of canvas transformation options, just like scale, rotate, to just change how the text is drawn on the canvas. So for example, we can scale it up by saying meme text scale. So by exactly the scale factor of our meme text. We can say after scaling it, we rotate it based on our meme text rotation value. So whatever the rotation value was here in our original editor. And then we finally need to calculate the final drawing offset, so where on our canvas this text needs to be rendered, for which we get the text centering offset, which is equal to our meme text constraint width minus the real text width divided by 2. So here, if we actually scale this up a little bit, not sure if I can visually show you that very well. We scale this up and then also edit this. Oh, come on, something like this, but make it a bit longer. Maybe make this a little bit longer, like this. This is good. So you can see here, our actual bounding box is quite wider than the longest line of our text. And this is the space here that we want to subtract. So in the end, we just really want to calculate this offset here. So the extra text offset due to this center alignment, because that's in the end what we also need to consider in the final export to render the text at the right position. Okay, so what we can now do is we call translate to move the text in the canvas by minus the box width divided by 2. We want to add our padding again, since that is considered in the original editor. So we also want to consider it in the final export. So text needs meme text padding x here. And we say minus our text centering offset. And the same thing for the box height, just that we don't have the centering offset here, since obviously text isn't centered in y direction. But also say divided by 2, and we add our text padding y. And then the very last thing here is we need to finally call the draw command, because right now we've only done transformations, but we want to say stroke layout first, draw this into a canvas, which is simply this, since canvas is what this here is extended with. Same thing for the fill layout, that draw this. And that is now what should render our text properly. So if we now go up, we're not yet finished, we still need to call these functions in the right order. We now, as a next step, want to say our output bitmap is now render meme, where the background is our input bitmap that we've created before, where our meme texts come here from the function meme text, just like the template size. So this is now the final bitmap with all texts rendered hopefully at the right positions, but it's still just an in-memory representation of that. We want to persist this, or at least temporarily persist this, so we can share this temporarily saved file with other apps in order to share it with other apps. And this works as follows. We will first of all get a file path. This file path comes from our save strategy. Get file path, and the file path is simply our file name. The file name is the file name we've passed in here. With that file path, we can create a file instance from Java.io, passing in that file path. And this right now is really just a pointer to a file path on the system. This is not yet a fully persisted file. In order to now really write contents to this file, we need a file output stream. So we send some bytes out to this file, pass in the file we want to write these bytes to, and then call use, get the output stream, no, not the bitmap, the output stream, because with this output stream, we can now use our output bitmap and say compress. Compress is a function on Android bitmaps that can be used to really write the real bitmap as bytes into a certain stream, like a file output stream. And that works by giving it a compressed format. This is simply the file type, bitmap, compressed format, and we choose JPEG here. Quality can be 90%, and the output stream is simply out here. And if that was successful, we can return this as a Kotlin result, .success, and we pass in the file.absolute path here. So the absolute file path, because that is then necessary for the next step in order to share this absolute file path with other apps. When something goes wrong, we first of all want to check coroutine context, ensure active in case the coroutine got cancelled here. Also don't want to dive too deep into why this is necessary. I have other videos. I have more advanced courses, Coroutines and Flows Masterclass, for example, in which I explain these things in a lot of detail. But this course is already long enough. It's simply necessary so that the coroutine here will never be in an invalid state. Afterwards, we can say result.failure with our exception that was thrown. We still get an error here. Because in our original platform meme exporter or meme exporter, we did not specify the output result of string of a file path. So here we can also say result of string, and here the error is now gone. Okay, that is how this works on Android, and hopefully works on Android. So we're now able to give this function our input text. This function will give us that as a save file. It will give us the file path of the save file of the image with all those texts being rendered. But in order to really try this out, we would need to pass a proper save to storage strategy. And in our case, since we will only implement this with a share sheet, where the temporary file can be shared with other apps, we will implement a cache storage strategy. So we will save this to the cache directory, which will regularly be cleaned up by Android. So in the meme editor data, let's have actually not, oh yeah, we do need this here. So cache storage strategy will be an expect class of type save to storage strategy. And here we have an override function get file path. Since the cache directory and the cache file path is also something that differs depending on the platform, we need to make this expect actual again. Hit Alt Enter here, create misactuals, again for Android main for now. And here we can now implement how the cache file path can be retrieved on Android. Since we want the absolute file path, this is something we can get with a file, return, file, context. We need the context here. Context.cache directory, pass in the file name here as a child. So that's actually the file name with the extension. And then we reference the absolute path, how easily this can be retrieved on Android. So now, as a next step, we need to provide the new classes with coin. So here in our app module, we actually need platform-specific modules as well, because here the meme editor view model is in our common code. Therefore, we can also provide this here in this single app module. But for example, if you want to provide the cache storage strategy for both platforms, then they may have different constructors, so we may need different modules here. This works by defining an expect val platform app module, which is just a coin module, and then we have platform-specific implementations just for that module. But we can then say we include this here, so this will automatically apply the platform app module the moment we apply the app module. So let's also go in here, Alt Enter, create the misactuals for Android main for now. And here we can say module, so coin module, where we provide the Android-specific implementations. For example, a factory of, so it always creates a new instance of the dependency here when it's requested, which is in the end what we should use for such rather short-lived instances that aren't very expensive to create. So we will have, on the one hand, our platform meme exporter. Do we need to import that like this? Platform meme, yeah. Platform meme exporter, and we say bind meme exporter class. This bind is necessary since this is hidden behind an abstraction after all, the meme exporter interface. So whenever we request an instance of meme exporter with coin, then it will use that underlying platform meme exporter here as the implementation that gets injected. Same thing for our storage strategy. We want to use our cache storage strategy and inject that whenever we request a save to storage strategy. And that's how this works on Android. On iOS, we probably need to implement those expect actual functions on iOS. We don't need to have the real implementation yet, but at least have the corresponding actual. So here for the cache storage strategy, let's go to iOS main and have that with the to do for now. Same thing for the platform meme exporter. Alt Enter, create this for iOS. So then we also don't have the error here anymore, since all our supported targets have an actual implementation. Lastly, I think for the coin module here also, Alt Enter for iOS main. This one we can already implement since it's almost identical to the Android one. We say on the one hand import platform meme exporter and then wrap this in a factory of platform meme exporter. and it binds the meme exporter interface. Same thing for cache storage strategy, which binds the save to store strategy. Okay, now that we have at least actual implementations of everything, let's slowly get to a point where we can test this already on Android. I don't want to implement the share sheet yet, since that is another platform-specific thing we would need to implement. But in Android Studio, we are able to inspect the Android system's file system. Therefore, we should be able to see whether the file was really saved at the cache directory. So when we click on Save Meme, we can say Save Meme. Is there anything that we pass in here? The meme template, Save Meme, create this function, meme template. And here in this view model, what we now need is a constructor with our meme exporter instance, with our storage strategy, and these will now be injected by Coin automatically. So in here, we can say view model scope, launch, and we say we use our meme exporter, export meme, and here we pass in the background image bytes, which we now need to retrieve first, which is in the end the byte array from the compose resource. We can then say this background image bytes, there's likely a function from Compose Multiplatform that lets us read in a drawable resource as bytes by passing in this environment, which is simply get system resource environment, and the resource we want to read in is meme template drawable. And this will read in this drawable here from our compose resources as a byte array. Meme texts, that is coming from our state, the current meme texts. Template size as well. Save to storage strategy is our storage strategy from the constructor. And the file name can stay like that. And I would say we just also give it on success. Add a print line here. Yippee, that worked. And we also print failures in case they happen. Where we just say, I think we get an exception here, right? Global. So we can just say print stack trace. So it means the moment we now click on save meme, we run our meme exporter, export meme, we save it at the storage strategies return file path, which is the cache path for Android. And if we see this, then we should hopefully be able to inspect that. So let's try this. Run the app, and here somewhere we can already take a look. Somewhere there is a file explorer here under this extra menu. Device Explorer. This gives you the file system of your Android device. Make sure it's selected, the right one. Specifically, under Storage, Emulated, 0. Is that the right? No, that's not the right one, sorry. Under Data, look for your package name. This is called CMP Meme Creator. And here you have this cache directory, which right now is empty, as you can see. You can also refresh this, synchronize here, but then nothing changes because we obviously didn't create a meme yet. So if we now go here and we add some text, so we say, okay, hello world, have a text here. We also want to rotate it a bit and scale it up. We add another text where we say, okay, smaller multi-line text perhaps. If we now click Save Meme, and we also take a look in Logcat, click Save Meme, it says, yippee, that worked. Doesn't yet mean that this really worked, but if we now click in the cache directory, then refresh this, there is our meme, a JPEG file. Let's double click, and that's looking very nice. You can see it's pretty pixel perfect. The texts are placed at exactly the right positions. That's very, very nice. I like that. Cool. First try. So I would say before we get to the share sheet here in Android, so we can send this file to other apps and also really save it persistently in the gallery that way, we implement the canvas logic on iOS. So we in the end now need to implement the same, just with the iOS specific system APIs in our, is that here? Platform meme exporter iOS, so here. But I think we will get through that a little bit faster, since I don't need to explain all these calculations in that much detail anymore, since I already went over that for the Android part. So all in all, just the APIs that we will use here will be a little bit different on iOS, but let's go through this step by step. First of all, let's also make sure we call all that on the right dispatcher, dispatchers.io. And in here we will also have a try and catch block, where we can also check for cancellation with ensure active. And in case something failed, we will also just return a result failure with whatever exception has been thrown. Inside the try block, we first of all want to call a function we create here, private function, called create background image. So this is the bitmap equivalent here in iOS, which is called UI image. We pass in the images bytes as a Kotlin byte array, and then get a UI image nullable with those image bytes as the background. First of all, that works creating image data by setting image byte dot use pinned usePint is an extension function here on Kotlin byte arrays in the iOS part, which just ensures that the image bytes arrays bytes stay accessible during this block when we actually create this image data. This is necessary because iOS has a slightly different memory system here that KMP tries to bridge with functions like this one here. So here we get those pinned bytes, and then we can say nsdata.companion.create, and here we can now create this image data by passing in these bytes from pinned.address of 0, so just starting off from the very first byte, and setting the length to image bytes size .to ulong, so an unsigned long, in the end just a positive number. We also need to Alt-Enter here to opt into this experimental foreign API for this entire file, and same thing for this create function, beta interop API. There's so many different types of APIs. Simply Alt-Enter, and then these warnings will be gone. Then we can say return UI image dot image with data, and we pass in our image data. So this now takes an NS data, in the end the iOS representation of a byte array here, and then we create a UI image with that previously parsed image data. So that's the first function on the call inside this try block, val background image, which is create background image, with the image bytes being equal to our background image bytes, and then with that image we can proceed to rendering the meme. So let's go down here, have a private function render meme. You may know this already. We pass in the background image, this time as a UI image instead of a bitmap. We pass in our meme texts that we want to render, and we pass in the template size in form of an integer size. There's so many different returns. Another UI image, nullable, which is the final resulting UI image in this case, with all the text rendered on it. Then we first of all want to say we have our image size, so the resulting exported image size, which will be an integer size, which we create with background image dot size, so that already has the dimensions here set into it. Use contents with .to int. So here use contents will just create a temporary copy of this value that we can, of the size value here, to make sure the image is still active. We can still reference its values, and then we reference the width, and we then create a copy of this width that we pass to this integer size we create here. Same thing for height. Use contents height to int. And now the way this works on iOS is we need to call certain functions here in the right order in order to move the canvas into a certain state and also draw something on the canvas. So for example, if you want to start drawing something on the iOS canvas, we need to start the draw context by saying UI graphics begin image context with options actually. This is what we will pick here. This first of all takes a size of type CG size, and we need to say CG size make, which will, you can see, return exactly that value. The size will simply be our image size dot width and image size dot height. And then we can say, okay, opaque is false, so it shouldn't be filled with anything. And the scale at this point, when just starting the context, can just be 0 as a double. And what is here the issue? Actual type is int, double was expected. Then we need to convert this to a double, I guess. To double. Then afterwards, we want to say val context, and this is now not the Android context, but a draw canvas related context on iOS, which we get with UI graphics get current context. And something that will happen a bunch of times here for us is that here you can see if we hover over that, cannot access class CG context, check your module class path. I wasn't able to find out why that happened. Our code will run perfectly fine this way. We will get the auto completion. We just get those unresolved class path issues. I'm not sure if we could fix this in any way by adding some kind of classes here, but it's definitely accessible, and it will definitely also compile later on when running it from Xcode. So we just need to ignore this issue and around it. If this context is null, then we say UI graphics and image context. So we explicitly need to say, hey, we are done now with rendering the image, and we would return null in that case. Return null. Next up, we want to draw our background. So we want to take the actual image, the background image, and after having created the real draw surface, we want to draw our image on it. And that works by saying image, background image, draw in rect. And here we need to define the rectangle in which we want to draw this image, which is coming from CG rect make. We pass in the X value, which is 0. Y is obviously 0, so we start from the top left corner. Width is equal to image size, that width to double, and height as well. Next up, we also need to calculate our scale factors, just like on Android. Here for that, we need a calculator instance. Meme render calculator is equal to meme render calculator, and the density here on iOS is coming from UI screen dot main screen scale to float. And with this calculator, we can then go down, scale factors, calculate scale factors in bitmap width, image size dot width, bitmap height, image size dot height, template size is template size. Then we can calculate our meme text or scale meme text. That's equal to meme text map, and we say meme render calculator, calculate scaled meme text for every single one of these scale factors, template size, like this. And then, just like on Android, we will take these scaled meme texts, iterate over these meme text. Here we can then have a draw text function that we will need to implement that takes in our context and it takes in our meme text. And then after having implemented that, as the last missing piece of this renderer, we can say result image is equal to UI graphics get image from current image context. So this will take the current image context that we've mutated here before via all these CG something draw and rect commands, gets that as an UI image. We say UI graphics end image context to say we are done again, and then we can return this result image here as a UI image in this function. So last thing to do is to implement the draw text function for every single text. Okay, doesn't work like that. Let's say private function draw text, which gets our current image context. So context in form of a CG context ref, and it will take our meme text in form of a scale meme text. This will then not return anything, and inside here we can implement the same logic, just equivalent for iOS. In order to create these text attributes, so what we've done on Android with the paint object, on iOS that works slightly differently. So here we're gonna have a little helper function, create meme attributes, meme text attributes, where we pass in our font size in form of float, and the stroke width, which we need to know in form of a float as well. And we then get back a map any to any. That's simply the format that the drawing text API here from iOS takes, where we just have key value pairs of specific properties about this text. On the one hand, we want to load the font, and on iOS we actually don't need to import any custom resources since the impact font is already a system font that is supported on iOS. So we can just say UI font dot font with name, reference impact as the name, and we pass in the font size to double. We reference the font impact on iOS with the corresponding font size. If that for some reason doesn't exist, we say we default to UI font bold system font of size, font size to double. Next up, we can set a paragraph style to set things like the text alignment. So NS mutable paragraph style, this is called. And after calling apply, we can change certain properties of that style, setting the alignment to NS text alignment center. And we want to set the line break mode to NS line break by word wrapping, so that we just say the paragraph should wrap when it exceeds the bounds. And then we can return a map off with certain properties about this meme text. On the one hand, NS font attribute name, we map this to our font. We map the property NS foreground color attribute. We want to map this to the foreground color, and this is white. UI color white color. The stroke color, so here we can draw these two together. Stroke color attribute name to UI color black color. The NS stroke attribute name to an NS number, and these NS numbers are really just Kotlin wrappers around the native iOS data types, because a Kotlin integer works a little bit differently than, for example, an Objective-C integer, which is kind of the one of the languages that iOS is based on and supports. And if we need to convert, for example, a Kotlin double here in this case to something that Objective-C understands, we need to simply wrap these in these NS-like type of data types. And if we just need to wrap a Kotlin number primitive into something that Objective-C understands, we need to put these into these NS wrappers. For example, our stroke width, and we want to pass the paragraph style attribute name to our paragraph style to link these. Then we can scroll up to our draw text function. Since first of all, let's create the text as an NS object again. So it's a string that iOS understands simply by saying NS string that create meme text.text. We then define our attributes, create meme text attributes. Font size is coming from the meme text scaled font size in pixels, and the stroke width as well. We can then calculate the bounding rect of that text. by saying text ns, or actual text, and we say bounding rect with size. So we get a rectangle that surrounds our text by giving it some properties, and it could be that this is here null, it seems like. Okay, let's pass in a size, cg size make. The width is simply meme text constrained width to double, and the height, well, is there something like infinity here? Max value, cg float max value, because in regards to height, our text is not limited in any way, but we want to give it a maximum constraint width so it properly wraps. The options is simply our 1L shift left 0. This is just the default option. Looks a little bit weird, but this is typical to write it like that on iOS. To make clear, it's a bitwise shift operation, so it's really just like on Android, in case you're aware, where you may have certain flags that you can append, and that's exactly what we can do here. On Android, it would be flag 1 or flag 2 or flag 3 in order to combine all these in a bitwise fashion. And here on iOS, it works with these shift left operations. But really nothing to worry about here for this particular parameter. What's more important is our attributes, which we get from, we already created these here, attributes. And the context for now can be null when it's still about just getting that bounding rect. Next up, we need to do the same calculations as on Android with the text height and the text width. Text height is equal to our bounding rect, use contents again, and that if that returns null, okay, we don't have a valid value, and then we return here. If it does, then we can say size that width to float, and the text width will be bounding rect, use contents, and here we can say size that width to float, and here it should be height, of course. We then say box width, just like on Android, with our text width, plus our meme text padding x, multiplied by 2. Same thing for the box height that goes around. Here we say text height, and we say text padding y. And then lastly, for the transformations that we apply, we again need to get the center offset, center x, by saying meme text scaled offset.x, and we simply add half of our box on top, just like what we did on Android. Center y, this is y, box height. So I guess it makes sense why we calculate it like that. If we have, if we have a text here like this, then here we have the actual scaled offset x position, and if we then add half of the box's width, well, then we get to the center of this box. Now we need to perform the equivalent draw and translation and transform operations here on iOS as we did on Android here at the very bottom here. This we now need to do in the iOS-like fashion by setting cg context safe g state with our context to initiate these transform operations. And then we say cg context translate ctm, so this is in the end the translate call, in order to move our canvas and what we draw on it. We pass in the context now, we pass in our center x as a double and center y as a double as well. Next up, we scale it, just like on Android, cg context scale ctm, context meme text scale, so the scale of the particular text here we want to apply, meme text scale to double, so in both directions we apply the same scale. No, not scaled offset, but scale to double. So here, this was again necessary in order to just scale around the pivot of the text, so around the center, scale it here. Next up, we need to rotate, cg context rotate ctm, also with our context here that references our current canvas context, meme text rotation. However, this angle here is in radians, not in degrees like it is on Android. So we need to convert this to radians by, again, multiplying this with pi, something we've also already done in our remember transformable states kind of thing, and dividing this by 180 to get this degree converted into radian values. And lastly, same thing as on Android with a text centering offset, which is equal to meme text constraint width minus text width, same calculation as there, divided by 2. And then we want to do one last translation, cg context translate context, and the amount we want to translate by is minus box width divided by 2 plus our meme text padding x to consider this again in the output. And then we say minus our text centering offset and convert this whole thing to double. Same thing for y. Here we say box height, meme text padding y. Here we don't consider the offset since it's in vertical fashion. So it's really the identical calculation as here on Android for this translate call, just that we call a different function with it. And lastly, we can then say text ns dot draw with rect where the rectangle is cgrect make. At 0, 0, we use meme text constraint width to double and our text height for the height. Don't be confused by these 0, 0. These will be drawn at the right positions since we apply the corresponding translate calls here to move the text to the right position if it was at the 0, 0 coordinate. That is how this works. Options, just like before when drawing this, options is again this shift left with a 0 bit. So in the end, this is really just 1. And I'm just doing this to make it more explicit that this is a bitwise shift operation. But the number 1 with a left shift of 0 is simply 1. Attributes is attributes and context is null here again. And then we can say cg context restore g state. So to restore the original state of the canvas before these calculations here, and then to redo this for the next text and so on, while passing in the context. All right, so that's now the equivalent implementation for iOS. The last thing that is missing, so of course we need to call this now, val output image is equal to render meme, background image, background image is our background image. The meme texts come from the function meme text here, and the template size is template size. If for some reason that returns null, we simply say result failure, and we pass in an exception, failed to create output image. And same thing probably here for the background image, which can also return a null result, failed to create a background image here. If none of that failed, we now want to take this output image and really also save it to a temporary file here on iOS. So let's implement that last, meme to file, and the image here is the UI image, the output image, file name we get, and the save strategy, which is save to start strategy. Let's maybe put these in separate lines, and then return a result of a string, so the absolute file path. So first of all, we get the JPEG data of that image, so the JPEG representation, which is equal to UI image JPEG representation, as the name says, passing in the output image, and the compression quality can be 90%. If that fails for some reason, we return a result failure, exception, failed to create JPEG image. We then say we get the file path from our save strategy, save to start strategy, get file path for the file name, and we then get the saved file by saying JPEG data, write to file for the file path we want to save this to, and we say atomically as true. And then saved is in the end the boolean, whether that was saved successfully. If that's the case, we return result success with the final file path, and otherwise result failure again with an exception, failed to save. I think this should be pretty clear, I think pretty logical, in which the order in which we execute these steps. So we can now go here to the export meme function, say save meme to file, the image is the output image, the file name is the file name, and the save to start strategy is our save to start strategy. Output image, what's the issue here? Actual type is any, but UI image was expected. What's the issue here? UI image, this returns the right type. Result image is a UI image. Interesting. What about the create background image? Also returns a nullable UI image. How can it come that background image is of type any? So this means this create background image, we need to return this here. Otherwise it tried to assign this result here to the background image. So we need to return this in with context. Same thing here when that is null. And yeah, now we don't have any more issues. And these ones here we can really ignore. Okay, that should be it for the iOS meme exporter. I'm not sure if we can inspect the iOS storage system in a similar way as an Android, but I would suggest we just go on with the last part. We're almost done with it, which is the share sheet that our share sheet opens, in which we can then either persistently save the meme or share it and send it to another app. So as you can guess, the share sheet opening that is also a platform-specific thing. On iOS, it will look like on native iOS, obviously, because it's a system sheet. On Android, just like it normally looks like on Android. So we just need a central API in the end in our common code that lets us trigger showing this share sheet. And then I have platform-specific implementations on how it really triggers for each platform. Let's put this in util under presentation. Call it platform share sheet. Make this an expect class where we have a suspend function in called share file. We need the file path that needs to be shared And do we need the MIME type? It's just JPEG here. We can then go to expect, Alt-Enter to create the missed actuals for, first of all, Android. So how does this work on Android? On Android, the platform heavily works with these URIs. A URI is in the end an identifier of some kind of resource. Doesn't yet need to be a file, but could also be a URL, for example, but could be something that points to a file. And there are now multiple types of these URIs. I have a separate video about URIs here on YouTube, on Android specifically. But what we want now is a so-called content URI. A content URI is in the end a pointer to a resource, a pointer to a file in our case, that will grant another app temporary access to that URI, to that file. Because generally on Android, the app that creates the file is also the owner of the file and has the necessary permissions to share it with others. And the moment we save our file on Android in the cache directory, technically only our app can read the file's bytes. If we now want to share this with another app, now that means the gallery app would actually need to access the real file bytes from our app. And that's what we can do with a content URI by generating this and by making our app serve like a file provider that provides files to other apps. And then the gallery app has temporary permission to read our file's contents, our meme, our generated memes contents, in order to then save that persistently on the file system. Or imagine you want to share this meme with the WhatsApp app. Then WhatsApp would also get temporary permission to read our meme in order to then send these bytes into the WhatsApp chat. This has the big advantage that we don't need to care about any types of permissions where we really manually save the file on the file system, but we just temporarily provide access to the file's contents to another app. And if that other app then has the permissions to write something to the file system, then it can do that and it can therefore persistently save it. So we first of all want to create a file at the file path, and then we create this content URI. This is created with file provider get URI for file. So we have a file. It's in our this specific file with a specific file path, and we want to provide this file to another app. We need the context here as well. So private val context, and then we say we pass this context to the provider. The authority is typically our package name. So context package name dot file provider, and we pass this file here. And then the next step is to take this URI and create an intent. So that's on Android really kind of an envelope with some kind of data that can be sent to another system component like another app with a certain intention. In our case, the intention is send. We want to send our file somewhere to another app. We can then say apply. The type is, so the MIME type here in this case, image/JPEG. We can say put extra to put some key value here into this intent, which is intent extra stream. This is how this works from the little extra where the resulting app where this intent is sent to can then read the contents from. So here, this is simply our URI. And we want to add a flag, which is intent, flag grant read URI permission, so that the app the intent is sent to is allowed to read from our URI that we've passed here. And we say flag activity new task, so that the activity of the other app is started in a completely new task. So if there is already an existing instance of this app running, it will create a new instance of that. Then we can say we create a chooser. So in the end, the sheet in which the user can then choose which app to share this with, and then all kinds of apps that satisfy this action sent that support receiving some kind of file or image will be able to will appear in this chooser. So also your Gmail app and all these kinds of apps, where we can simply say intent create chooser. The target intent is our intent from above. Title can be null, and then we say apply, and we say we add a flag here, which is also intent flag activity new task. So just like for our intent. And lastly, we can say context start activity with our chooser. So this is the final intent that when sent will open our platform share sheet on Android. Now, out of the box, this won't work because this file provider is a so-called content provider on Android, which is a component on Android, just like an activity, a broadcast receiver, a service, and that has to be registered in the manifest so that Android will really create this file provider for us because then it will be able to share content. That is what a content provider is used for. First of all, here in Android, so Android main, res, we want to create a new Android resource directory, specifically an XML one with some extra XML metadata, in which we create a new XML resource file, which we call file_paths. Also call it like that. The root element here can be a paths object, and then creating this. This is in the end now the XML file in which we define in which file paths in our app's internal storage, the file provider will look for sharing, or will support sharing these files. So we, for example, want to have a cache path here. We could give a name like meme cache, and the path is simply the current working directory. We may want to have the same for the file path, so the real persistent file path, outside the cache by saying files path. And the same is actually also applicable for external file paths. So external cache path, then we have the external files path, and just the external. So we have meme external files path, meme external files, and meme external cache. So just different locations for the file provider to look for when we are about to share a file. And then in our manifest, as I mentioned, we need to register this file provider, just like the activity here inside the application tag. And this works via provider to register a content provider. The authorities, that is our package name. So just like what we also passed here, this is in the end what we now need to register. So com, in my case, PL coding, CMP, and what is the exact package name? This one. Make sure to copy yours and don't just write off mine. That file provider. The name is file provider, so that is an Android system content provider component. We set exported to false, so that not other apps can talk to this file provider, but is more or less internal to our app. We're going to say grant URI permissions to true, so that the other apps can also really access the URI that we share with them. And then we finally share our just created XML metadata file, where the name is equal to android.support file provider paths. Also spell it like that. That's just the metadata attribute name that Android expects here for this. And we pass a resource of XML at XML/file paths like this. And then we close this off. This should be it for Android. Let's of course wire this together. This means we on the one need to go to app module in the platform app module to provide now the instances of our file provider, of our share sheet. Here we are in the Android platform app module. We create a factory of platform share sheet. What did we call it? Platform share sheet. And we have that here. Let's maybe first of all implement the iOS variant so that we at least have an actual implementation of that. And then we perhaps can go back to our, where is it? To our DI app module Android. Here we have a platform share sheet. There it is. Double code it in before. And we don't need to bind anything here since this isn't backed by an interface, since it is a presentation layer component that is also only used in the presentation layer. So we don't need this interface here in order to bridge these layers. Same thing for the iOS specific DI module, app module iOS. Paste this here, and that will be sufficient. In our view model, meme editor view model, we now want the share sheet of type platform share sheet. And now instead of running the meme exporter here directly, we want to run this directly, but if it was successful, we want to use our share sheet now and share this file that our export meme function has returned. So the success case, we simply take the temporary file path that we've retrieved and saved in the export meme function and pass it to the share sheet so that other apps can access the file at the underlying file path as well. Let's run this. Let's see if this works on Android. We still need to implement the share sheet for iOS, but that is relatively low effort. So let's pick a different meme perhaps. Here, this one, we add a text and let's leave it as it is. And we click save meme, then it crashes. Okay, what is it? Scrolling down, illegal argument exception, failed to find configured root that contains the file. Okay, why? So it seems like the file could not be retrieved here. Let's maybe take a look in our device explorer if this file exists. So CMP meme creator, there we go. Going in the cache directory, refreshing this. Here we have the file with CF70, and here it is. If we double click that, that is our meme. That is looking correct. But I'm not sure why we then get that exception. Let's take a look in the meme editor. Happens here. Platform share sheet. Let me perhaps investigate that off camera, and then I'll get back to you once I've hopefully fixed it. Okay, that just took me 10 seconds, and I immediately noticed it. Here in our file path, the files path attribute was previously named to meme cache as well. So we had two meme cache attributes, which we of course don't want. We want to rename this to meme files, so we have unique names here. If you make that change and you rerun the app and you add a text and you click save meme, our share sheet opens. And here we can really then take a look at all these apps that can receive some sort of image. And here on my pixel, at least, this would be the option that really saves it on our file system. If we do this, then here is our meme with our just exported text. Isn't that beautiful? Very nice. Let me also implement this now for the iOS side with the iOS specific share sheet. Here, platform share sheet iOS, and it in the end works in a similar fashion. Not necessarily with these content URIs, but yeah, let's just type this and then we'll see how it works.
First of all, a file URL is needed on iOS, which is an NS URL, file URL with path from our file path. Then we can have items to share. So technically you could share multiple items on iOS, but we just want to have our single file URL. We then create an activity view controller, which is then used to trigger the share sheet. So set this to UI activity view controller. The activity items are our items to share, and the application activities that we can set to null. Then we also need a so-called root view controller, which is equal to UI application, shared application, so the application instance on iOS, key window dot root view controller. If that doesn't exist, we can throw an illegal state exception, no root view controller found. And then lastly, this root view controller can then be used to just overlay certain items on that root view, that's on our app's content in the end, just like a share sheet. So we can say root view controller dot present view controller. The view controller to present is our activity view controller. Animated we can also set to true, so it's animated. And when it's completed, so completion, we don't need to do anything specifically. And I'm just noticing this doesn't need to be a suspend function, I guess. Let's not make this a suspend function, because I also don't think on Android we need this to be suspending. So let's go to, where was that? Here, platform share sheet. This also doesn't need to be suspending. All right, let's try this on iOS for the very first time as well. We haven't yet ran this app a single time on iOS, I just noticed. So I think that is what we need. In order to run this on iOS, you could technically do this from here by selecting iOS app, but in my experience, this was sometimes a bit buggy and you had issues here. First of all, it's important that this project is, the Kotlin part of the project is successfully built, for example, by launching it on Android. But then we want to open this in Xcode. So here, this iOS app folder, specifically this one, is what we want to open in Xcode. And originally there was an Xcode option here with open in. Now it's not anymore. So let's open Xcode manually. And yeah, that was something we also already made a change in here with the init coin, just not an Xcode. But this is my prepared project, so this is not the one that I've opened. You would simply need to go to File, Open, and then, well, open the file path here from Android Studio. You can also open this here in your Finder. There you go. And then right-click, Get Info, and here you can copy this as a path name if you don't want to navigate there manually. So I'll quickly open this, and then I'll see you back in a moment. So I've opened this now, but maybe important for you to know, please open this Xcode project file that you have here. So CMP meme creator, then you have the iOS app folder, and inside there you'll find this Xcode project. That's the file that contains all the Xcode related project metadata and which files to open in which order. And then it will look something like this, where we can now select a simulator here on iOS, for example, iPhone 16 Pro, and hopefully be able to just run this. Here you can click on run. Yeah, you will notice that sometimes it complains about a missing Compose app module. That's not a big deal. This was usually fixed if everything is at least connected successfully after the iOS build. So you can see it's now building, and once that has been built, I will see you back, hopefully with a working app. And no, it didn't build successfully. So we in fact got that issue, no such module Compose app, and we got an argument type mismatch. Actual type is float, but double was expected. Seems like we need to convert this text type property here to a double. Let me go to platform meme exporter here. That's where the issue happened. Here, it's marked as an error, but it kind of hides a little bit between all these other errors we could ignore. So let's convert this text type to a double and then try this again. This could have been the reason why Compose app module wasn't properly imported, since there was simply a compile time error. And it launches. You can see it's currently initializing. First launch in the debug mode is always a little bit slow. But here's our meme creator app on iOS. Let's select some kind of meme. There we go. Can we add text? We can, and we can also drag these around. Here on iOS, you can, what is it, which key? For me, it's the Alt key. We can hold that in order to get this pinch to zoom gesture you can use here. So let's do that, and we can edit our text. We can double tap here. We can make this something, move this here. If we then click Save Meme, then it takes a little moment, but okay, we get a crash. Interesting. Why do we get a crash? The file path does not exist on the file system. Okay, what is that? File path does not exist on the file system, so it seems like it's not properly saved in our platform meme exporter, because here is where we write this data to a file, to the file path. Do we maybe have the wrong strategy here for iOS? This is the issue. We haven't yet implemented the cache storage strategy on iOS. All right, let's quickly do that. Of course. That means we need to get a cache directory equal to ns search path for directories in domains in order to find this directory. The, what is that here? The directory is ns caches directory. The domain mask is simply user domain mask, and the expand tilde is true. So on some file paths, you have this tilde that corresponds to the local users directory, and this would simply expand it to a full file path. We can then say first or null to get this cache directory, which right now is just any. Convert this as a string, so this is the file path specifically, and if that doesn't exist, we throw an illegal state exception, could not find cache directory, and then we return that cache directory together with the file name that we've passed. Just like that. And I guess we already provide this here. Yep, let's run this again. Not on Android, but on iOS here in Xcode, and take a look. There we go. Here, let's take one meme. Add some text. Also maybe scale these up a little bit so we can really test this. Have another text. It's a little bit difficult here to scale up multiple ones when not being in the center, at least in the simulator. Let's maybe also edit this a little bit. Here, hello, something like that. Move this here. If we now click save, then yeah, now it shows. And you can already see the rendered image, but it's not exactly right with the text. I think there's something wrong, but let's take the image and we can save this to files here on my phone. No, it should actually save this as an image. What is wrong here? Cancel? Save to files. Okay, let's just try this. Save here, but it doesn't save this to the gallery for some reason. This is an older one, but it's not in the gallery. Okay, interesting. Something is wrong here. Could take a look at files. And we should be able to see it here. Okay, it doesn't draw the text with a white fill, but you can see the texts are drawn at the right positions, but not with the fill. And it's not saved in the gallery. There is no option to save it there. Okay, I'll take a look at that. Okay, those were in the end two issues. On the one hand, we have the issue with the just the stroke being drawn, and on the other hand, we have the issue with that the image can't be directly saved in the gallery. That is an easy fix, something that I just forgot about. We need to do something similar as on Android when working with the manifest, when declaring permissions. On iOS, if we actually want our app to be able to save, in this case, photos directly to our gallery, you need to go to Xcode, info, this is kind of the iOS manifest equivalent. And here you need to add this attribute by adding a specific string here that explains why the app needs photo access. And then the moment the app tries to send a photo to the gallery, a little permission dialog will open up. We don't need to add anything else in order to make this work, but you do need to add this property. So in case you don't have this, I'll copy the text for now and remove it again. You would need to right click here, add a row, and then search for privacy. And here under privacy, there is some kind of photo editions usage description. And here you set this as the value, which will show up in the permission dialog. And with this, we will also get the option to save this directly in our apps gallery. As for the stroke issue in Android Studio, that's actually quite a tricky one. And it's, in my opinion, a super weird way from iOS to handle this. Because we do set the stroke width here via our stroke width, but we need to make this the negative stroke width, because this is in the end how iOS decides whether it just wants to draw the stroke, or whether it wants to draw this with a stroke and fill color. And if it's a positive value, it will just draw the stroke, but if it's a negative value, it will draw the stroke and the fill color that we've set here. It's super stupid, but it is how it is. So we need to set it like that. Let's relaunch this with these changes, because then everything should hopefully now work on iOS as well. Let's select the meme. Let's add some text here like this. Let's maybe edit this, make it span some other lines here. Maybe also rotate this one here. A bit annoying here on the simulator. Yeah, like this. And if we now click Save Meme, we do get the share sheet. And you will probably get a permission prompt the first time, but I've already accepted that in my fixes. Here we now have the save meme, the save image option, in addition to save to files. And this is what will save it directly in our gallery. And you can already see it's now also considering the fill colors. If we click save meme and then go back, in my case, the gestures don't work here. I need to hit Command-Shift-H in order to minimize this. Go to photos, and here is our new meme. So it seems like we have a pretty working app. Something that I also wanted to check is the landscape layout here. So if we are, that's not the app, but let's launch this on Android. There we go. If we are in the meme editor and we rotate the screen, we don't want to lose any values. So here, adding a text. If we now put this in the center, in a which is not a square, we still expect it to be roughly in the center after rotating this. And yeah, that's actually another thing we need to fix, that in landscape mode, it actually should fill the height and adjust the width accordingly, since we are on a wider configuration in that case. That's something we need to fix in the meme editor screen, specifically, in the draggable container. Here we render the image. No, that's not where I want to do this. Draggable container. Where do we place this? Where do we render the image? Here, that's the image. And by default, we say the content scale is fill width, so it fills the entire available width and then just scales up the height so it's not distorted. And in landscape, this looks very weird because we want to check here if our, is it parent size? How did we call it? Window. Need to get the window size here. Well, window size is equal to current window DP size or integer size, that doesn't matter. And then we say if that window size, that width, is larger than window size, that height, that means we are on a landscape orientation, or at least we are on a device where the width is wider than the height. Then we want to set this to content scale, fill height. So we first of all expand the height and then adjust the width based on that height. And otherwise, we set it to fill width. Relaunching this, trying this again. And now if we select this meme here, add the text in roughly the center, rotate, then, what's that? This is, why is the image, it needs to be fill, does it need to be fill max size in that case? No, it would actually need to be conditional as well. So here for our image modifier, if we are in landscape, we want to fill max height and otherwise fill max width. So we say that then to apply a conditional modifier, if window size width is larger, shrink this a bit, is larger than window size that height, then we say modifier fill max height, otherwise modifier fill max width. Giving this another shot. There we go, selecting that, add text, and now rotate. Yeah, now it works exactly as we would imagine. Also, if we rotate this a little bit, then the rotation and all that stuff should remain as it is. Yeah, perfect. Let's lastly change this little weird icon, which would be a normal back arrow. So we say it's arrow not left, but arrow back. And then if we launch this once more, this should be a proper back arrow here. And it is. And we can go back. Very nice. We have a fully working meme creator app. Was a long video, a long course. I really hope you learned something. But I also really have to say, what we've done here in this course is just the absolute tip of the iceberg when it comes to industry scale mobile development. There's so much more to learn when it comes to databases, remote APIs, things like real-time connections to a backend, responsive UI also on larger devices with a larger app, authentication, offline first development, so much more. Of course, the entire architecture around that. So if you're just a little bit serious about learning Kotlin multiplatform on that industry scale, check out the Kotlin Full-Stack Developer Bundle, which I will link down below, which will really help you to build such apps, not just for Android and iOS, but for 5 different platforms and a backend. So I'll put the link down below. Thanks so much for watching this far. I really hope you enjoyed this video. If you did, leave a comment below. I think you can imagine how much work and how much time needs to go into such a video, from preparations to recording to editing. So we are definitely here at multiple full-time weeks that go into such a course with multiple people being involved. So show some love in the comments. Thanks so much. And I will see you back in the next video here on YouTube in case you're new to this channel. definitely subscribe to not miss further such videos. Bye bye.